Nice to be in orbit.
Discovery's 4 computers now have primary control of critical vehicle functions.
Welcome home, Columbia. Beautiful, beautiful.
Nice to be in orbit.
Discovery's 4 computers now have primary control of critical vehicle functions.
Good morning, good afternoon, or good evening, wherever you are joining us from around the world. Welcome to day 2 of 5 of Agility Prime Week. We are so excited to have everyone back. I'm proud to report that we had over 6,000 people watch the live feed yesterday at some point during it. Not a few people stayed on for all 6 hours of interactivity and an amazing lineup, but over 6,000 people overall. Thanks so much for joining. A couple things coming up in case you weren't here yesterday. One, we've got artists capturing all the content in the background to summarize all the amazing speakers that you'll hear today. So look for those images. They'll be broadcast live, and we're putting up on social media as well. So you can use the images to take back to your teams and share the amazing work that the Agility Prime team is doing. We also are saving all the videos as well. Those will be up on agilityprime.com. We're loading those almost after they happen, so you can review any of the sessions and any of the speakers that have come before. Of course, we'd love you to stay tuned for the live sessions we have coming up, because we have some pretty amazing interactive elements that are becoming your way. First, YouTube. You can see the conversation and chat to the right of your screen. We're going to engage with you there all day long amongst yourselves. We'll also be pushing out polls, questions, so that you can have direct feedback into what the speakers are saying and doing over the course of the day. We have a Slack channel for those dedicated flying car enthusiasts and builders. Please join the Slack channel. That link will be coming up in the chat as well shortly. Don't forget, hashtag Agility Prime. Promote this out on social media. And before I turn it over to our host and Agility Prime lead, just a quick preview of today. Some amazing speakers. Nate will talk about those. This afternoon at 1 o'clock, we're going to have artificial intelligence help with networking of the topic you want to focus on and the exact people you want to meet. The lawyers won't say, I can guarantee you'll meet people that will change your life and your career, but I'm pretty sure that there'll be some amazing networking experiences that happen. In fact, yesterday, when we did the networking, 90% of people voted to stay on networking an additional half hour. Pretty amazing. Also, to bring your attention, tomorrow morning, we'll be trying to break the world record for largest number of virtual breakout groups, all focused on flying cars and the amazing CEOs of the companies we have coming up. Pretty exciting. Nate and I didn't do our best job of introducing ourselves yesterday. I just want to share that I'm from the AFWERX and Difference team. We like to think of ourselves as a catalyst for the Agile Air Force engagement across industry, academia, and non-traditional contributors, possibly like a lot of you in the audience right now. We try to create transformative opportunities to foster a culture of innovation across the Air Force, partnered with academia and commercial companies. Our goal is to solve problems and enhance the effectiveness for all of us through deliberate, thoughtful, ground-up innovation across the wider industry. And with that said, I'm Brandon Klein. Coming up next, Agility Prime CEO and lead, Nate Diller. Colonel, over to you.
Super, thanks, Brandon, and thanks for the fantastic day that the team put together yesterday. Outstanding conversations. We had leaders from Secretary of Transportation, the Secretary of the Air Force. We had our executive for the Air Force, our Air Mobility Command commander, and then, of course, Dr. Roper talking about the strategic importance that this program could play for the United States Air Force and for our country. We then got to hear from Mark Moore and the promise of that technology. You'll get to hear from Mark again today, so just a little bit of a teaser. And then we spent the afternoon talking about what could the world look like if we actually had these types of vehicles, if we actually had the opportunity to fly orbs with U.S. government. So after all that promise, fantastic future that lies ahead, but that comes first with a lot of really hard work. And we've got to build trust in those systems, and particularly in those passengers. And I've got with me here this morning one of my frequent passengers. She and I made our first flight in a glider above the beautiful Pennsylvania landscape. We were climbing up into the sky, and after a little while, I noticed she started getting quiet. She had a smile on her face, and it slowly started to fade a little bit. And I started asking her, are you enjoying the airplane ride? How's everything going? And this went on for a while. And finally, kind of in an outburst of fear and frustration, she goes, why do you keep calling this an airplane? In her mind, an airplane was not a glider. It was an airliner that had nice seats and everything else. And so as we start to look at these new passengers, as we start to look at the passengers of the future and the vehicles of the future, we have to make sure that we're building that trust. And that trust comes after a lot of really hard work by professionals that One are doing tests. So you're going to hear this morning some of our fantastic testers, to include the commander of the Air Force Flight Test Center, who leads the most fantastic and the most advanced flight test of any organization in the world. We're going to hear about the airworthiness process and how we're working together with the FAA, with NASA, the civil authorities, and potentially getting to opportunities to fly these vehicles sooner. But before all of that, we're going to hear from our PEO, Miss Rutledge. But to do that introduction and to explain the critical importance of having the rigor that an Air Force Program Executive Office brings to a program like this, I'd like to introduce again the Program Manager for Agility Prime, Natasha Tolentino. Natasha?
Hello, everyone. It is an honor and a privilege for me to introduce Ms. Linda Rutledge. She is a member of our Senior Executive Service and is the Program Executive Officer for Air Force's Mobility and Training Aircraft Directorate here at Wright-Patterson Air Force Base, Ohio. She has been with the Air Force for a number of years, which will be coming to an end here soon, which I am devastated about. But without further ado, I would like to introduce Ms. Rutledge. Ma'am.
Good morning, everyone. I think I'm on right now. So I'd just like to say thank you for allowing me the opportunity to speak today and introduce this next segment that we're going to go through, which is really talking about the execution piece. Yesterday, you heard the overall vision from our Air Force senior leadership, and you also heard from our what we call our warfighting integration capability group there with General Hynode and Colonel McKeever and various other warfighters and what they might do with this type of capability. And then this morning, we're going to focus a little bit more on the execution side of this. How are we going to implement this? So I think we have some charts up. So on chart number 2, I kind of laid out, so what is a program executive officer and why am I involved at all? This chart here will give you a view of a portfolio of a program executive officer. This is mine. We all have similar portfolios within the Air Force, but mine consists of the mobility and training fleet. Specifically on the mobility side, it's the airlift piece of it, the C5, C-17, and C-130, and then I have all the aircraft trainers for the Air Force. And what I do there, it's primarily an execution role. I'm really responsible for development, production, sustainment, and then modernization of those aircraft. And you can look at the list, and most of these are old, with the exception of T-7, which is currently in development. Everything else is fairly mature in the life cycle. But day to day, it's really my job is to keep these airplanes flying and to keep them viable for many years to come. So you might ask, why would a program executive officer be involved in something like this? There isn't a requirement. And that's normally how we operate. We receive a requirement from a major command. Heard from General Miller yesterday. Her command would be one that provide me many requirements. And Dr. Roper really wanted to set this up so that we had a very agile construct. And he brought a program executive officer in to try to provide some rigor to the program so that we could quickly transition once we find out what that requirement is. So that is what's different. And it makes a lot of folks uncomfortable because normally in our world, we start with a requirement, we derive system requirements from that, and then which we derive system specifications, we build it, and then we field it and make sure it meets those specifications and requirements. Well, in this case, we're doing a bit of a tech push. And it's not that we haven't done this before, and it's usually about the game-changing technologies that we do the tech push. And so I think that's an important message for Agility Prime, that the Air Force believes in this so much that it is putting the resources to do the tech push on it. And a lot of folks say, but there is no requirement. There is no requirement. And well, that's not unusual. And I told this story very early on when one of my major command counterparts, operational counterparts, said, well, we don't have a requirement for that. And I said, you don't yet. You just don't know it. And I used this little Jewel here, my iPhone. And I will tell you that if you had asked me 10 years ago what my requirements for a phone were, well, 15, 20 certainly would have been differently. I might have been able to imagine a little more innovatively 10 years ago, but never would I have written a requirement that allowed me to use this when I travel to find my way, to take pictures, to send videos, to communicate at all times and hours of the night, and to be able to complete my Christmas shopping in the airport and have my packages on my doorstep by the time I got home. I never could have imagined that. And I think that's where we are with this, even though that, we can envision some cases that we might use it for now. I think that is what the Agility Prime program and how we've structured it is all about, is allowing us an opportunity to take some fairly mature technology, putting it to some use cases, and just figuring out what we can do with it. And it's the build it and they will come. So I truly believe there is a requirement for this. We just don't know quite what it is yet. So let me talk a little bit about how we've structured the program. So if you go to the next chart, we have set this up with a program executive officer oversight, and that's myself at the time. And we've realized that we have the technologists, we have the, usually we call the operator generating requirements, and then we also have our execution arm, which is normally a program executive office in the officer with its system program office. So we have brought all of those parties together to operate in an integrated product team environment, and Colonel Diller is heading that entire thing up for. So he's looking across the entire gamut. And so we've pulled our objective overall is to field something by FY23. And I say something because we are very open to what that is. What we will provide as part of our program executive officer construct is the expertise, the rigor, the structure of program execution. And the other thing is driving risks down in all areas. And so we focus on that life cycle. I talked about me being responsible for the life cycle of all those legacy systems. Well, we need to work early up front to make sure we have those abilities in there. And that's also what we're trying to bring to the table as part of how we have set up this program construct. Looking at the reliability, the supportability, affordability, safety, security, all of those abilities that we feel are important in the fielding. Now, having said that, we do for a minute think we're fielding an F-35 type weapon system within the next 3 years. That is in no way, shape, or form. So we do understand that this is a 100% solution, but we want to build in all of those abilities that we can and that are appropriate and easy to do early and upfront as we continue to grow this technology and the capability. We're trying to bridge this, what we call the valley of death, between technology demonstrations and then moving into programs of record and ultimate fielding of capability. And so we have proven before that this is the construct that works to do that, is working as this IPT early on and upfront to work to the same requirements that in some ways we have laid in and created, and moving that through our life cycle very quickly with agility to be able to do something this fast. So if you look at the next chart, that our government team is set up. Now, this is quite different. It doesn't look like a typical program office. It doesn't look like a typical laboratory project, advanced technology demonstration type project. And it doesn't look like an early requirements analysis of alternatives either. So we've pulled all of the parties together, the Air Force Research Laboratory, which is our technology development arm in the Air Force. We've brought the Air Force Warfighter Integration integrating capabilities office together. And they really are bringing that overarching requirements picture across the entire Air Force versus individual operational commands. Of course, we have our ventures office in the Air Force that we're working with to try to bring that investor strategy to bear. And then we have our typical functional execution, which is our normal, what we consider our project manage, our program management, our program office type of capability where we are executing contracts, cost, schedule, performance that you would typically see in a program. So we feel like this is our model for how we can avoid a valley of death and field a capability that we can begin to understand how we can use it in the military and what those ultimate requirements would end up being. Now, if you go to chart 5, we would look at reducing risk to industry. We do believe the market is ripe, that there's capability out there that we could bring to bear and be able to provide some of what we can offer in terms of ranges, test, airworthiness, and drive some of that risk down for industry while we are figuring out the best utilization of this type of technology for the Air Force. And so we've set the program up to be able to expedite fielding and strengthen our industrial base, partnering with investors and offering what capabilities that we have. We're looking at a collaborative strategy as the systems mature toward certified commercial platforms. We'll identify those that have opportunity and for early adoption, and then we will put together a program and requirement to execute that by 2023. If you move on to chart 6, so we're going to talk a little bit more specifics. We have used our rapid contracting authorities to put together what we're calling the Agility Prime Innovative Capabilities Opening. We've already put out a request for information back in December, and we've broken our offerings or areas of interest into 3 heats, or you'll hear them called heats or areas of interest. The first area of interest was released back in February. We've gotten several companies and responses to that. And as of today, we either have or will be releasing, but by the end of today, we will have our area of interest 2 and 3 released. And of course, our area 1 was 3 to 8 personnel, had other criteria with it. Areas 2, 1 to 2 personnel, and areas 3 are unmanned cargo. And so there's the areas we have pushed out there. We have laid in criteria to give you an idea of what we're looking for. And then the next step is we will work with those companies that meet those criteria to work through a contractual construct that makes sense for both of us, with what you bring to the table and then what your needs are, with the objective of getting something, a flying capability, by the end of this calendar year. We are using we would put together a no-cost other transaction authority. So just to be clear, we are looking at industry to bring their ready capability where they have already invested research and development type dollars into that. And we would be wanting to take that and provide our in-kind support for test and airworthiness and work through that to then ultimately be ready to go into a production and fielding by 2023 of some small quantity of these systems. So you're going to see, I've talked a little bit about the execution, where we might go with this. And again, we're open right now. We've said electrical VTOL and then urban and advanced mobility aircraft, but we are open to hear any of the ideas you have as part of this. We've tried to give ourselves a lot of liberty in how we've opened this, and agility in how we can construct our contractual vehicles and work with you all to meet your business model and then meet our needs as well. So we are very optimistic that we're going to be able to put programs together with viable companies to be able to get us to something in 2023 to help us understand how we can use this technology in the future. We're also, I saw a few questions in some of the chats yesterday asking about funding. Yes, that is a challenge. We have about $35 million between now and next year, and we are working funding streams for follow-on. We're also working funding flexibilities that will provide us a way to be more flexible as we identify technologies that we can move very quickly through the process. So we've got a lot of things that we're working within our team that I laid out earlier. And you're going to hear a lot of the details from some of that team. You'll hear from Natasha again in terms of the program management side. You'll hear some of the contracting details that give you more information on the AOI 2 and 3. Then you're going to hear about our test strategy in terms of the program, Agility Prime program, followed by, we're very fortunate to have Major General Chris Azzano, who's the commander. He's our lead tester, development tester in the Air Force. He's responsible for all development testing. And he will open and then have some of his folks talk about resources and all the test resources that are available and test expertise that we have within the Air Force to offer. So I think you're going to learn a lot more today about our program. We are excited about all of the players and looking forward to responses to our 2 and 3, which will be released today. So with that, I thank you for your time, and I will turn it back over to either Natasha or Nate or Diller to lead us into the next phase. Thanks, everyone.
Thank you so much, ma'am. I do believe Brandon had one comment that we needed to get out to the public.
Well, first, let's thank you, Ms. Rutledge. We are going to turn to the audience now for the ability, like yesterday, for whoever wants to participate in these discussions. There is, of course, the Slack community and the YouTube channel, but I'm putting up now a poll where you can ask and vote exactly what you want to hear. So our first question of the day today is, what topics most interest you or would you like to hear more about this week? We have put A through F, so follow the instructions on screen. You can even text message in your answer. If you want Agility Prime Airworthiness, text in E to the number on the screen. And you can also follow those instructions in Slack and in the YouTube for links to these voting mechanisms. Our team is in the background looking at the results. We will publish them publicly so everybody can see, and we will adjust the questions, the content relative to what you, the audience, want to hear more about this week. Thank you for engaging with us. Keep those chats going live and entertaining, and well, not too entertaining, content focused. But Natasha, back over to you to introduce our next set of speakers.
Thank you, Brandon. All right, everyone. The next subject that we're going to be talking about is how we're going to be innovative with contracting. Ms. Rutledge had the opportunity to give you a lot of information. And with that, I will introduce Mr. Tyler Prince. He is our agreements officer and a fully warranted contracting officer out of the C5 program office.
All right, thank you, Natasha. Good morning, everyone. My name is Tyler Prince. I am a contracting officer team lead out of C5 supporting the mobility directorate. I also have a warrant as an agreements officer, which will help lead the discussion for our innovative capabilities opening, ICO, the corresponding AOI's area of interest 1, 2, and 3. And just an update on the AOI number 2 and 3. They were posted yesterday afternoon. So please head over to the ESAM and take a look at those. So we'll also be going over general and specific contracting strategy for Agility Prime. So as we head on to slide 2, go a little bit over the agenda, go over some general contracting and kind of purpose and how we're supporting Agility Prime. And then we'll go more into the focus areas of the actual ICO, the different areas of interest, and then get into some short-term and long-term goals for Agility Prime. And then after that, I'll try to answer any questions to the best of my abilities. Also, if there are any other questions after this, feel free to submit those in writing, and the team will work on those and get those out upon the ESAM for everyone to take a look at. So as we go into slide 3, just the overall purpose. So contracting offices, we have, typically, we see a lot of our strategies come out of FAR-based contracting. However, there's been a recent push and emphasis on non-FAR, specifically other transactions. While this isn't new, it is something that we put a lot of emphasis on and will definitely be ingrained in the culture that we have for not only acquisition strategies, but the way that we kind of execute contracts or agreements going forward. So as that kind of is ingrained into our culture, it'll help us better understand our acquisition strategy, and that'll hopefully lead to expediting program fielding, decreasing lead times, and helping to support technical acceleration. So as we go on to slide 4, why are we here? So we're here to kind of give you the strategy of the Agility Prime and an overview of what we're going to be doing going forward. So we intend to use the non-FAR based other transactions. So 10 USC 2371, that will be the authority, other transaction authority, OTA. Specifically, what we'll be trying to award off these are other transaction for prototypes, OTP, which falls under 10 USC 2371B. So this will help facilitate market readiness for the vertical takeoff and landing technologies via prototype projects, focusing on non-traditional contractors, but there will also be opportunities for traditional defense contractors as well. So take a look at our ICO and the AIs, and those will definitely give you some insight onto who would all be qualified or be able to kind of bid in this environment. Like I said, we're interested in feedback. If you have questions, please let us know. We're also interested in different alternatives that we can use to successfully move forward with this program. These proposed technologies may incorporate, but are not limited to, non-traditional electric or hybrid propulsion, manned or optionally manned missions, onboard pilot, remote pilot, and autonomous control. So as we go on to slide 5, again, how are we doing this? We're going to be doing this, as I said before, via the other transaction for prototypes, OTPs, again, 10 USC 2371B. Definitely recommend anyone take a look at that so you can kind of understand the qualifications, kind of the definition of what a prototype is. It's a pretty broad example, so definitely looking to use this going forward for our program. So we're seeking some prototype projects to assess this vertical takeoff and landing technologies. Prototypes can include, in general, commercially available technologies with novel defense applications, prototype demonstrations, agile development activities that can improve commercial activities, any combinations of existing government-owned capabilities, and it could even be common practices that are newly applied for broad defense application. And again, please check out the ICO. That'll give a definition of what a prototype is, and the specific AOIs will also give a definition of what the actual prototype we're looking for each corresponding AOI. So as we go into slide 6, we'll touch base on our innovative capabilities opening. Again, that's our ICO. If you think of, while this is non-FAR based, if you kind of look at it through the same vein of a BAA, this is our broad general announcement of this with the corresponding AOIs to be what we plan on making award off of. So again, we're going to be using this for the OTP 10 USC 2371B. This is considered to be a competitive solicitation. Each AOI has specific response times, so definitely take a look at that and make sure of knowing how long you have to submit a bid. But at the same time, think it is like an open BA in the sense that we have the ability to evaluate and award these as they come in. So if you have a great solution, please submit those to you as soon as possible, and we'll start to evaluate it and see if we can move out with these. The competition, again, are released via the AOIs. AOI 1, 2, and 3 are all posted on ESAM, so they're all for the public to take a look at and provide solutions on. The AOI responses will be evaluated in the 3 phases outlined in the ICO that we'll get into in the next couple slides. We do anticipate this to be an iterative process. Like I said, we're already starting to receive proposals, solution briefs off our AOI 1, so we're going to evaluate those and see if we can move out on any of those. And like I said, we'll continue to do the same process for AOI 2 and 3. Another important thing to foot stomp from the ICO is that these prototypes may move directly into production once the prototype is deemed successful, delivered, and viable. So that's definitely something that we want to foot stomp that. Yes, we're soliciting for prototypes right now. We have those 3 phases. But if these are deemed successful, we do reserve the right to potentially move into a production contract down the line. So if you have any questions, the ICO has language in there that determines what a successful prototype is, what the prototype itself is defined as. If you have any questions, please reach out to us so we can make sure that you understand that what the prototype is, what it's going to take to be deemed successful, and that we may move down to a production contract down the line. So as we go to slide 7, this goes over the overview of the different phases for the ICO. There's 3 different phases. The phase 1 is what we're currently looking at right now for AOI 1, 2, and 3, solution briefs. So that will be for industry to provide us your solution briefs. Again, we have them for each one, so we'd like to see them come in for all 3 phases. We will review, evaluate them as they come in, and move on. From there, we'll go into phase 2. So what that will be the company engagement. After we receive solution briefs that we feel comfortable with, we might move on to more of an engagement session, maybe face-to-face, maybe a demonstration that will help us give us a better understanding of your technology, your solution brief, and will help us lead down to potentially moving on forward to phase 3. And phase 3 will be the request for a prototype proposal. So this will be the engagement of an actual agreement in place. So again, it wouldn't be a FAR type contract, but it is a binding agreement. So like I said, after your site visits, if we think that we want to move forward with you, we will submit that formal request for prototype proposal. And once we move on from there, we'll look to negotiate and award these prototype agreements. Again, all 3 phases are posted. Please go to betasam.gov, and we can definitely send out a link to the specific ICO with all the 3 AOIs. So they should be out there for you to take a look at. So as we go on to slide 8, we're looking at the initial AOI. So this one is for, again, as Ms. Rutledge spoke about before, is the 3 to 8 personnel. So each AOI is going to be for different. The 3 to 8 for 1, AOI 2 will be for 1 to 2 personnel, and then the unmanned for AOI 3. So specifically for the initial AOI, tend to test the hypothesis for that vertical takeoff and landing technologies. And so some of the specifics that we're looking for in each AOI. So it is important to look at each AOI to help you provide your solution brief. So mechanical simplicity, lower maintenance costs and time, autonomy, help us improve safety and lower personnel demands, mass production, helping us for affordable quantity, distributed propulsion, improved acoustics, and then runway independence, greater flexibility, and reduced infrastructure needs. So again, please pay attention to the AOIs to what their actual prototype is. For AOI 1, this is a test report, acceleration certification while assessing the value of early government adoption and fielding. Again, early government use could occur prior to civil certification. So moving on to slide 9.
Hey, Tyler, this is a fantastic presentation. Thank you so much. And I'm also watching the audience here. They are starting to light us up with questions. So take maybe 30 seconds, another minute to finish up the presentation, then we'll open it wide open for some great questions coming in. That sound good?
Sounds good.
Awesome.
So slide 9 just gives some more specifics of what the AOI entails. So just take a look at those. They're going to be different for each AOI. So we'll move on to slide 11. Short-term goal, award all these AOIs. We have, again, 3 AOIs out there. Make sure you pay attention to the date, to the submission dates. And then long-term goals, while we're looking at the benefits for OTs to ensure flexibility, access to that new technology, we are also looking for potential long-term goals of maybe doing more traditional contracting, BAA, SIBRs, or CRADAs as well. So we're really looking at any different ways that we can make this program successful. So slide 12 just has again, I'm the agreements officer, Tyler Prince, and then Sarah Bowler's our contract specialist. If you have any questions, feel free to submit those and we'll do our best to get those back to you as soon as possible. So at this time, if there are any questions, again, I appreciate you guys taking the time to let me brief this. And if there are any questions, I'd be happy to answer.
That was great, Tyler. And just to let you know, 772 people watched your presentation there. Thank you very much. And now over to Natasha and Nate for fielding some of those questions coming in.
Sure. Tyler, thanks for that. And thanks for the great work that you've been doing Very exciting. We've been having a lot of requests over the last couple of months since we released Heat 1 of the Air Race, that AOI 1. And while we have some folks who have submitted to AOI 1, there are a lot of others out there who are looking to use this AOI 2 and AOI 3 to get involved in the Air Race to certification. And we feel like we've got, between the three of these, a really nice portfolio of things to explore those different parts of the orbs that we see into the future. There's one question, though, from the audience. What do they do if they're not fitting within the scope of the current AOIs? And so those of you who have not had the chance, you can go onto agilityprime.com under Join the Race, our Air Race, and you'll get those documents to understand more. But Tyler, tell us a little bit, what if they don't fit the requirements that are there right now? Are they done? Are they not able to join the Air Race?
As far as the technical requirements, or just the in general meeting the depth? So I think in order to bid to an OT, you have to be either a non-traditional contractor. And we have that definition out there in the ICO, not subject to CAS within the last 12 months. That's the short version of that. But there are opportunities to work with larger businesses as well. So they would have to meet some sort of criteria in the OT guidance in that USC code. But if they don't specifically fit one, that doesn't mean that they won't be able to fit into something down the line. But as far as, if they're a small business and not subject to CAS within the last 12 months, they should be able to fit into that non-traditional definition as defined by the law.
Thank you, Tyler. One of the next questions we have is, what are Air Race government evaluators looking for in particular outside of the strict requirements? For example, what are the main criteria?
So the main criteria as listed, so that's listed on the ICO. So I definitely would recommend you taking a look at that. As far as, I'd have to pull up the actual ICO to go over the technical requirements. You might have some technical expertise on the line as well to see what we're looking for on these. But it's laid out in the ICO of kind of how we're going to evaluate, and in the AOI, as further briefed towards the end of my slides, let you know like the different areas of the acoustic, the specifics of the technical requirements that we will be evaluating based on your solution briefs.
And I'm going to follow up with that for just a moment. We do have the request for information also posted as one of the documents out there. And just from a process perspective, again, to reiterate what Dr. Roper said yesterday, our intent is not to have a requirements document. And so what we've done is we've taken feedback from that request for information, from our work with NASA, FAA, and industry study to shape what we think are interesting and available technologies that are out there. We would like to keep that open. The fantastic work that Natasha and Tyler have done under Ms. Rutledge has allowed us to continue to evolve our contracting strategy based on the feedback that we're getting from all of you. So if you have ideas, please submit those to the RFI. And then just one other piece to reiterate from what Dr. Roper said yesterday, we are very interested in solutions that have commercial applicability. We're not writing military specific requirements. We don't see these as military specific aircraft. And so from that perspective, what we are looking to do is take something that you already think has commercial viability. We'd like to understand your business case. We'd like to understand how you are going to generate revenue from this. And then we would love to figure out how we might also generate savings to the taxpayer by flying these under a similar government use case. So I think that's helpful. Natasha, I'll go back over to you for probably one remaining question until we get into airworthiness with Frank Delsing. Tyler, thanks a lot.
Thank you. Tyler, one last question. I know that you are not a tester, and we will have a test segment coming up. However, how are we defining a test plan as a prototype? And then how do we define the success for that?
So, I think in general, the idea of a prototype is, the ICO defines what the prototype is, and then the AOI will be specific to that test report. So I definitely recommend you look at that language of what that test report would be. But at the same time, the definition of a prototype is very open in the 10 USC 2371 be. So we think that test report will result in a prototype that we can use going forward to potentially award these prototypes, not only for the short term, but also the long-term goal of potentially keeping an open mind and maybe being able to move into a production type, either OTA or standard FAR-based contract. So the AOI, each AOI is going to have their own specific prototype involved in those. So, but we do believe that test report, as far as the utility and going forward to meet our missions, it fits into that definition.
Thank you so much, Tyler. With that, I will give it over to Colonel Diller.
Hey, before we head over there to Colonel Diller, I've been watching the results of the poll, and I know the minute by minute agenda coming up. And Nate, I think this is kind of a fun one because the way we orchestrated the agenda, and now if we put up the audience poll live, it's kind of amazing just how we, I guess we designed their agenda right. So congratulations to you and your team. Airworthiness is at 35% of the votes, by far the most number of votes. And guess what's coming up next in the agenda?
Fantastic. Yeah. We'll bring forward next Frank Delsing to talk about this great and important topic of airworthiness. Frank Delsing is a graduate of the Air Force Test Pilot School. He's flown a variety of mobility aircraft in the past, and he currently is serving as the Director of Test for the Air Force Research Laboratory. He's done a lot of great work previously in test, helped bringing to field the Air Force's newest training aircraft, and couldn't think of a better person to be leading this very critical topic and execution of this, already working with some of the companies that are out there to start working on this airworthiness problem. So Frank, over to you. Thanks for joining us this morning.
Thanks, Nate. Never realized I was so popular until I got my information out on a poll there. So thanks for the opportunity to talk here today. I know airworthiness is something that a lot of people have a lot of questions about. So I'm glad to have this chance to kind of go through it and present at least some introductory kind of information on it to make sure that we're all kind of working together towards the same goal. So if we can go to the set of slides there, you can see in slide 2 the overview. I'm going to start off with just kind of going through some definitions, a little bit of compare and contrast between what you see in the FAA and what you might see in the Air Force airworthiness process. Then we'll get into why exactly we're here, why we're talking about airworthiness with respect to Agility Prime, what you can expect on the Agility Prime program going forward with respect to airworthiness, especially in light of all the contracting stuff that you just heard. And then I'll try and leave enough time for questions so that we can address some of the questions that people might have directly. So if we can go to the first slide, slide number 3, if we talk about airworthiness between the FAA and the Air Force, when I was the airworthiness lead in the lab a couple of years ago, I spent a lot of time teaching scientists and engineers about airworthiness. And the way I like to present it to them was, look, airworthiness is something with respect to flight test, it is really just an engineering second opinion. So it's getting some fresh eyes onto your design, using some recognized and proven standards that we can measure your design against, and making sure that we have a safe and efficient design. So in the DoD, they specifically define airworthiness as the ability to safely attain, sustain, and complete flight all within operational limitations. So if we can meet that definition, then we are an airworthy platform. So if you look at the slide that we have there, when it comes to the oversight responsibilities, to create an airworthy platform, you see the Air Force and the FAA are really no different. You have to start off with a design that is approved to some standard. That design then has to be produced. So your production article has to represent the design that was approved. And then you have to operate and maintain that production representative vehicle in the intended manner that was original with the design. And that's the same across both sides, which makes sense. If you get to the process owner on the FAA, I'm sure you're very familiar with the Aircraft Certification Service, Air 700, with their compliance and airworthiness divisions. In the Air Force, we have the Air Force Technical Airworthiness Authority, Mr. Tom Fisher, who is responsible for both the policy, airworthiness policy in the Air Force, as well as the execution of the airworthiness process. So that's where that process is designed and executed out of that office in the Lifecycle Management Center, based here in Wright Pat. And then if we get into the management and control of airworthiness, you can see in the FAA you have your ACOs. On the Air Force airworthiness side, again, that's that airworthiness office here at Wright Pat that is owned by Mr. Fisher. The standards are very similar. There's a lot of overlap. There are areas where they are different, though, and that's something key to understand. You've got the 14 CFR various parts. I know with a lot of the vehicles that we're talking about here, it's a mixed match of different parts because we don't have an eVTOL part to 14 CFR. So, and in that respect, it's actually very similar to 516C. We take the pieces of 516C that apply to the design as presented. Interestingly, as a test pilot, I always like to point out that 516C started its life many, many years ago as a pre-flight kind of checklist for experimentally designed aircraft. So it started off as here are the things we need to look at before we go take an aircraft into the air, and it's obviously grown in complexity and since then. But it is very similar to 14 CFR parts, and we tailor our certification criteria based on the design as presented. And then when we get into airworthiness approvals, in the FAA, you've got your standard type certificates, and supplemental type certificates. In the military, we have a military type certificate. So those are pretty similar. But we also have something called a military flight release. And even on the military type certificates, that one of the areas where you see a significant difference between the FAA and the DoD is that the FAA's specification compliance, understandably, because they are certifying an aircraft for use by really anyone that is authorized to use it. In the military, we're authorizing use for the military. So we have a little more control over how closely a design needs to meet specifications. So we will set out our certification criteria. We will evaluate the design against that criteria using the artifacts that are presented, whether it's analyses, modeling and simulation, flight test data, ground test data, wind tunnel data, whatever it takes to show that your design meets compliance. And if it doesn't meet a compliance, then we evaluate that gap, that delta between what the specification says it should do and what it actually does. We assign some hazards and risks to that, and then we then hand those over to the operational users to say, look, we've evaluated this design. Here's your engineering second opinion. By the way, here are areas that maybe it's not quite what we're used to, and here are the potential consequences and risks that go with that. And then it's up to the operational user to decide what to do with those risks, whether to accept them, to mitigate them, or to just say, I'm not gonna fly that platform. It gives us a little more freedom in terms of operational use based on what the user themselves feel is warranted. And then finally, I wanted to point out that under special airworthiness certificates, we hear a lot of talk about experimental tickets. Some of the vendors have been issued experimental tickets, which is great, and that's kind of a first look on the FAA on the design. We don't have anything like that in the Air Force, mostly because that first look is not necessarily against a set of specifications. It's really just kind of okay, you can go test your platform to start meeting those compliance, to start gathering the data to meet the compliance. But there really is no design evaluation per se in an experimental ticket. So even in our military flight releases, we still evaluate the design to some level, and so that we can evaluate those risks. If we move on, so that's the background. Now moving on to the next slide, which is what I think more people care about, is why we're here. So why are we talking about airworthiness on Agility Prime, and what can we expect there? So in the near term, why we as the airworthiness team for Agility Prime are here. And in those AOIs, what we really want to do and the way that we want to accelerate commercialization of your product is to help you gather that data and to help you gather the information and the artifacts that you need for your FAA airworthiness certification plan. So it's the plan that you've already worked out with the FAA on how to get there from here. And so if that means that maybe you need some access to some DoD facilities or ranges where we can maybe provide some coordination. So some examples, we have anechoic facilities where you can do some of your electromagnetic testing of your systems there, radios and that sort of thing, looking for interference. We've got environmental testing capabilities. We've got noise testing facilities. So if you're not aware, we have the aviation or the acoustic research complex out at White Sands that can do a 3D kind of 4-pi steradian evaluation of the noise levels of your aircraft in flight. Which I think is a pretty spectacular capability. So that's kind of an example of something that might be of interest to you, or just even access to some ranges that provide you the airspace that you need to develop the data that you need. So we can provide some of the access to that. We have technical expertise. Things like, and I'm sure most of your companies have this too, but we've got guys that are working on high voltage and high capacity airborne electric systems. We've got cyber, GPS, autonomy with complex functions, digital engineering. We've got all those kinds of expertise in the Air Force, and we're not saying that we can do it any better, but if you need maybe just somebody to talk to get kind of like we said, a second opinion or some advice on approaches, then we can provide that for you. And then finally, if you need, some of these ranges might require some kind of airworthiness from a DoD perspective or beyond the experimental certificate. We can help with that too, and we can tie that to your collaborative flight plan, flight test plan. And so in reality, what I'm actually saying is, yes, we are the government and we are here to help, believe it or not, for real. In the long term, what is this going to do for us? Well, for us, it's going to help us to understand your systems, help us to understand the eVTOL space and some of the innovative technologies that are there, so that we can help to design and help to support that within the Air Force airworthiness process. We can support you as the industrial base, because the better the industrial base is, the better off we are in a program like this, certainly. And then we want to look at and potentially field, obviously, dual use capabilities, because that's where we really see advantages to the DoD and the Air Force, while at the same time using systems that already exist there. So next slide, when we get into what to expect. So you heard about the AOIs. So we now have 3 AOIs on the street, which is great. In phase 1, that's where you as a company provide a solution brief to us. And you'll see a lot of the questions that are asked in the AOI probably look a little designy and airworthiness kind of flavor to them, which is because we're asking questions to help us get up to speed on what you're doing. But what we really want to know is then tell me, how can I help you? What kind of things can we do to help you get to FAA certification data that you need to get to your civilian cert? And so at the same time, while we're learning about your system, we're also trying to help you get there from here. So then AOI phase 2, that's when we get the direct engagement. You'll see that we can have that discussion on what specific kind of resources. You tell us, hey, we need some help with this area, and then we can help. We can provide maybe some resources in terms of facilities or ranges or expertise where we can do that. At the same time, we're going to bring our airworthiness team in there, who are dedicated to this program, to start getting an idea on your design. Maybe not to necessarily critique the design or even present or provide that second opinion initially, but at least to get smart on it, and also so that we can get an idea of where we need to adjust our process to help with future certification of these platforms. And then finally in AOI phase 3, that's that request for prototype proposal that you heard earlier. That's where we're looking to come up with collaborative test plans to generate the certification level data for you, for your FAA certification plans, and will most likely be flight testing on civil certification. So you'll be using your X ticket or whatever kind of certification that you have to fly at a DoD facility. That's the idea there. And then if there's any delta there that the range requires, we can provide that. And then finally, the last slide there, in terms of long-term, what can we expect? Well, I've got my airworthiness team engaging the broader airworthiness community that's out there. So it's not just the Air Force, it's not even just the FAA. We're out there with NASA. We're talking to the other services. We have a whole airworthiness council of recognized airworthiness authorities. And so we're engaging with those players to make sure that there are things that, that other people have been working on in other areas, and we can learn from that. We don't need to reinvent the wheel there, and make sure that we're all supporting each other. And then the big thing, and one of the tasks for my airworthiness team, is to develop that roadmap so that we can get the transition to an operational platform in the future. So we're going to leverage the work that you've done with the FAA. We're going to look at areas where the FAA has already maybe set some certification standards that we don't have in 516C yet. If you get a type certificate out of the FAA, maybe with some STCs, we can leverage that because we recognize the FAA as an airworthiness authority, just like they recognize us as an airworthiness authority. So we don't have to revamp all of that again. We can leverage all that work, and you don't have to start from scratch. And we're going to the biggest thing is identify gaps in our current DoD criteria where we need to kind of push the rope a little bit and make sure that we're developing what we need. And then, so in the end, we're going to come back to the Technical Airworthiness Authority, to Mr. Fisher, and advise him on some unique aspects to consider as we look to certify this next generation of VTOL. So in many ways, when you work with us, not only are we trying to help you get there from here, but you are also helping shape the way that the Air Force airworthiness approaches this problem as well. So it's a great opportunity on both sides to work together to come to a solution. So on that, I'd like to leave it open. I think we've got a little bit of time for questions and see if there's anything that we can address in this forum.
Super, Frank. Thanks so much for the time. And just so you know, you're not only popular, but you're increasingly popular. You're increased every second you're on, so we're going to hold you for a little longer. Here's a very interesting question that a lot of people, and I'm pretty certain you might not give the most satisfying answer. The question: how long does it take to get through airworthiness?
Yeah, so I'm gonna use the standard "it depends" answer there. So it really does depend on what your ultimate goal is, and it depends on what you walk in the door with. If you walk in the door with an FAA type certificate, and the only change we're making to the airplane is we paint it gray instead of white, then it's a whole lot easier than if you walk in the door with a design on a piece of paper and you say, I want to build this and I want to have it certified. So, and then there's obviously gradients in between that. So it really comes down to how much work in terms of certification has already been done on your design. How different is that design that you're going to fly from what you actually want to get certified, and what do you want to do with it? So, you hear the horror stories about, an F-35 type system, which is exquisite, designed specifically against a set of requirements, not really used anywhere else outside the Air Force or the military kind of regime. So their airworthiness process was huge. And because of what they want to do with it and the design, we're talking about a much smaller subset of that here. So I would not expect it to be on that order of magnitude.
Super. Can I give a follow-up to that question? I think if can you just explain kind of in the simplest terms, what for the folks that maybe have been spending a lot of time thinking about design, what do the artifacts look like? What are they presenting? What type of work? What is it that makes airworthiness so difficult? And you'll hear, companies talk about, as you said, millions of dollars, maybe hundreds of millions of dollars to get through this process. What is hard about airworthiness, and what is it really from a nuts and bolts perspective? What does this look like?
Yeah, as an engineer, the way I look at it is you don't get to You don't get to pretend that your analysis is always right in terms when it comes to airworthiness. So just like when you're going through school to become an engineer, your instructors will say, okay, you've set up your problem this way. You've got this analysis to show that it's good, but prove it. Why should I believe that analysis? So, if I come up with, let's say I have, from a structures perspective, I have a finite element model of of the entire aircraft or subsystem or something like that. And I say, look, this finite element model is good. And it proves that I've sufficiently designed margin into this system. And the question then is going to be, well, how do you know it's good? What kind of validation have you done against that model? Have you done flight tests? Have you done some kind of proof testing? Have you done some kind of ultimate loads testing? These are the kinds of things that they look for in the airworthiness process to lower that risk. Because really, airworthiness is just saying, I have a certain level of risk because I don't know enough about your design. And then as we add in kind of proven methods to show that the engineering is good, we lower that risk to an acceptable level. So I would say things that you want to see are, you want to see analyses, you want to see simulations, you want to see validation and verification of those. There are areas where you just have to go flight test it. You start to get into some of these nonlinear regimes where it's very difficult to model. Things like transition from vertical to horizontal flight is difficult to model. And a lot of times the best way to do it is just to go fly it. So it's just collecting all of that data so that you make yourself satisfied that you have brought that level of risk down to an acceptable level.
So as we follow into that, what are some of the challenges that you've seen, and when would you think among the companies that are out there, when should they start engaging with you to get an idea and understand where they fit into the Agility Prime process?
So I would say engagement it starts in the AOI phase 1. That's where you kind of give us an idea about your design. That's why we have those questions in the AOI. So your engagement really starts when you submit that proposal in phase 1. And then when you get to phase 2, that's when we kind of start the interaction. That's when you can start to get a feel for the kinds of things that we're interested from an airworthiness perspective. Some areas where I've seen in the past that people have had some hiccups, a lot of times it happens from trusting models and trusting simulations without validating them, without showing that, okay, I assume that my structure has this much strength, and now I'm going to run a simulation against that structure, but you've never shown that your structure actually has that much strength, whether through some kind of proof testing or ultimate loads testing. I go back to structures a lot because that was my flavor of engineering back when I started, but it transfers across engineering disciplines. Whether in electrical designs, you design your system and you can run simulations of your system, but sometimes building a copper bird where you show actual lines being utilized for actual actuators and designs and things like that, then you can find problems that your analysis just doesn't show. And so you got to have that kind of real world plug-in to the analysis and the simulation.
Okay, Frank, we did have one more question. Okay. What has been your experience teaming with the FAA? Is there genuine focus on finding a path to certification for orbs in the FAA?
So my interaction with the FAA so far is that they are definitely committed to finding a path for this kind of eVTOL, UAM, AAM, whatever we want to call it, whatever we want to call this space. They are plugged in and they want to find a path to certification. As far as our path to certification and our interaction with the FAA, we actually have in Nebraska, we have a military certification office whose sole responsibility is to give us that kind of transition between FAA and DoD airworthiness. So when we go to buy civilian derivative aircraft and we turn them into military aircraft, that MCO helps us with that transition between an FAA type certificate and a military type certificate. So that path is well laid out. We know how to do that. And so that's one of the other reasons that we are so committed to helping the users or helping the vendors in this industry get to their FAA certification, because that only makes it easier for us in the long run.
So What are the ways that you see these companies? What we don't want them to do clearly is have to go through, we've got the NASA national campaign, we've got the FAA certification processes, we have some joint customers that are out there that are, as you saw yesterday, very interested in this. Last thing we want to do is have these companies go through 5 different airworthiness processes. What do you envision so that we're able to kind of streamline this process? What does that look like to you and to the others that you mentioned in this airworthiness process across the other organizations?
Yeah, so streamlining the airworthiness process, a lot of that comes from the way we've set up the AOIs. So getting that early engagement with a dedicated airworthiness team is going to help us get insight into the designs early so that we can set up the system to get to that ultimate certification in the end. So by bringing us on board early on and having the design discussions, it gives us the ability to build that pathway now so that when you get to your FAA type cert and now you want to go from FAA to military type certificate, we know what that delta is, and it's just a matter of just checking those boxes in that delta rather than starting from the beginning and going, oh, okay, I don't know anything about your design, so let's design a whole new certification criteria for the military. We don't want to do that. We want to leverage the work that's already been done and really just address those few deltas between the already certified design and what we want to use in the military version.
Super. And as a follow-up to that, well, Natasha, I'll let you go ahead.
No, so Frank, there was one more question just to follow up as Colonel Diller was kind of talking to. Tell us more about the interaction between airworthiness and test.
That's a great question, especially being an airworthiness and a test guy. I live in both worlds. So really test is there to, whether you're talking ground tests, you're talking lab tests, you're talking flight tests, they're there to generate the data and the artifacts and the information for the airworthiness side of things. So in reality, what the test guys are going to be doing is setting up ways of collecting that data so that then you can take that and give it to the engineers on the airworthiness team to say, okay, here's the proof you asked for to show that this design meets the requirements that are there in the airworthiness process. And then on the flip side, the test guys then lean on the airworthiness guys to say, okay, when I go fly this thing, is it going to act like it should? Is it as designed, as advertised? So there's a very close interaction there between the test and the airworthiness.
So what is it about this process? How do you see us potentially being able to go through this process a little bit faster from Agility Prime? Again, knowing that this is new technology, there's some standards that haven't necessarily been established. What do you see is the key points that will allow you to go at the pace that the technology is there and available? Can you tell us a little bit about how we're going to do this and see this world that will be here sooner than we think, according to some of the zealots? And there's a lot of zealots out there based on our survey from yesterday. So can you prove it to them?
Sure. So I would say in the first kind of tranche of interaction, that's where you get the AOIs. That's where we kind of lean on your ability to fly in a civil respect. The next beyond that is when the Air Force starts paying you to fly, or we buy a vehicle to do tests and to do experimentation. That's where our airworthiness team is going to work with you to find a way to develop that military flight release. So like I mentioned before earlier in the brief, a military flight release is kind of a more of a risk-based assessment of your design. And one of the ways that we're able to do that is because the MFRs are tied to a specific set of limitations, maybe tied to locations, certainly tied to a time frame. So it takes the full envelope of whatever you want to do, and it shrinks it down to what you need to do to conduct your test. And so what that means is that now you can go and fly this thing within a test kind of environment with a limited amount of airworthiness documentation available to you. And then as you fly it more, as you test it more, you develop more, you're able to grow that envelope out, and you're able to expand it to what you need. And then final phase would obviously be buying operational systems. And so by the time we get to that operational system purchase, the idea is we've already been through these other segments with a dedicated airworthiness team, taking you all the way from your experimental cert with the FAA through your military flight release tied to specific test plans, all the way to a type certificate, hopefully from the FAA at that point, and then we just do the deltas for the military type certificate. Add to that some things that are a little different for this test plan, and I don't want to steal too much thunder from the test panel that's coming up, but maybe a little plug for the test panel is we want to look at new and innovative ways to test that. And by finding new and innovative ways to test and experiment, we can also leverage that to help us on the airworthiness side as well.
Super, Frank. Thanks so much. I believe that this will be a conversation that we certainly are going to continue with the audience. This is critically important. As I mentioned, we've got millions and potentially billions of passengers that are out there that will eventually reap the benefits of the hard work that's going to happen here to ensure that we're preserving that safety. And thanks also for the great segue into our next segment, which is test. And so I would like to next introduce the Air Force's #1 tester and the commander of the Air Force Flight Test Center at Edwards Air Force Base, General Chris Azzano. General Azzano directs a $31 billion enterprise of more than 18,000 military and civilian contract personnel across Edwards Air Force Base, Eglin Air Force Base, and Arnold Air Force Base. The test center provides development and test evaluation of experimental and research manned and unmanned aircraft, space, and cyber systems, something that we'll talk about later on this week, and the importance of that cyber testing, as well as supporting DARPA, NASA, and international partners, and very important, creating the new testers through the Air Force Test Pilot School. General Azzano is flown more than 2,900 hours and 35 aircraft as an instructor pilot, evaluator pilot, and experimental test pilot. He's conducted developmental testing on a wide range of aircraft and weapons, and has commanded the squadron, group, and twice at the wing level. So General Azzano, sir, thanks so much for joining us. Thanks for the mentorship that you provided the testers out there, and thanks for the excellence that you continue to flow into our testing. Over to you to tell us how we might look at testing a little bit differently for Agility Prime, and tell us about the great work that the Air Force Test Center has been doing.
Well, thank you very much, Colonel Diller. I really appreciate the opportunity to be a part of the Agility Prime rollout. It's my privilege to represent the Air Force Test Center today and to offer some opening thoughts before the flight test panel. The Air Force has an amazing legacy in flight tests going back decades with leaders who have helped forge our pioneering heritage. Test pilots like Glenn Edwards and Fitz Fulton, Chuck Yeager, Pete Knight. And today, the Air Force Test Center is 18,000 strong, innovative airmen forging our nation's sword and shield. There are many obstacles as we develop airspace and cyber systems to support our nation's defense. Yet we do it safely and effectively, which is a testament to the professionalism of the broader test community. Agility Prime is beginning a pioneering leap of its own today, and we'll soon hear from a number of test professionals, including some of our own leaders in the test center. Our audience will also have a chance to ask them some questions. Before they start, I'd like to offer several of my own thoughts as you embark on this exciting new mission for the Air Force, for the Joint Services, and for the commercial sector as well. First, the challenges of capability development in aerospace and defense are massive. The technology is complex, the environment is unforgiving, and the human element is essential. Combine those and you have a recipe for an exhilarating experience underscored by the harsh reality of what could happen if things go wrong. In flight tests, we celebrate early discovery so we can fix the flaws in our aircraft and ensure that they are safe and able to adapt to Air Force missions while we adapt those missions themselves. We have a long legacy of agility, recent efforts to develop a light attack aircraft, a commercial space internet, directed energy weapons, and rules of the road for autonomous systems all have benefited from a rigorous, disciplined approach to capability development. Lean, aggressive, agile teams, but informed, disciplined, and rigorous in their undertaking. Which brings me to my second thought. The foundation for accelerating technology in aerospace and defense is world-class risk management, and we apply it every day in flight test. Risk management doesn't mean avoiding all risk. It means tirelessly mitigating hazards and in the end, accepting only those risks that we can balance with well-defined objectives. And as we build this new vertical lift enterprise, all of us, you included, have a sacred obligation to our nation's warfighters and our fellow citizens to develop safe and effective aerospace systems. What makes it to the field must work. Dr. Roper has said that rapid does not mean reckless, and I could not agree with him more. I often tell our airmen that sometimes to get there faster, you need to tap the brakes a little bit. And those airmen are the cornerstone of my third and final thought. As I mentioned earlier, aviation is an inherently human endeavor, and Agility Prime will be no different. Your customers, the beneficiaries of your technology, and the incredible teams you compose to design and test your aircraft, they are your human element, and they are your secret weapon. These teams will be the foundation of your success. Get your test teams involved in design and risk reduction early. We have found early test involvement to be the key ingredient in any successful technology development venture. Listen to your flight test experts and applaud them for their independent thinking and candor. They are natural problem solvers who detest inefficiency, but they're also realistic about the challenges of science and technology. Their wisdom will guide you through development and help you reach your dreams and deliver on your promises. In the business of defending our nation, there is no one good source of good ideas. Sometimes they come from the warriors in the field, sometimes from industry, sometimes from the lab or academia. I'm convinced the good ideas that blossom within Agility Prime will come from all these sources, including all of you. You are embarking on an exciting adventure, and I wish you well. It's time to get talking about flight test, and I can't think of a better way to kick off that conversation than a highlight video, your Air Force Test Center in action. Thank you. Let's roll the video.
Excellent. General Zano, sir, thanks so much for a fantastic introduction, for underlining the importance of the work that's going to happen on test and continuing that long tradition that our testers have done to make sure that these vehicles that fly through the air are maintaining the highest level of safety and security. And thanks especially for getting to see some fantastic air power by the United States Air Force. We look forward to getting a few of your comments here as we close up the test session. But before that, we have a lot of fantastic discussion, and I'll hand it over to Natasha to introduce our Agility Prime test team. Natasha?
Hello, everyone. And it was a wonderful test discussion, but it's only going to get better from here. At this time, I would like to introduce both Mr. Terry Cross and Mr. Ryan Plumley. They are both our Agility Prime integrated test team leads.
Good morning. Thank you very much, Natasha. I appreciate the opportunity here to discuss testing. I just saw someone mention in the chat, this is the fun part. So I think that we have a very unique proposition here in Agility Prime, the ability to offer the resources the DoD has in testing expertise and range and capabilities for this program. I think that what we're really able to do here is offer these in-kind resources to these VTOL vehicle developers as they're maturing these concepts and accelerating them and mitigating some of the risks to get to commercial operations. You know, these folks we're looking to work with have a lot of experience with their technology, and they're maturing these designs. What we're looking to do is talk to them and figure out where do they need support from the resources the DoD has, and how can we then make them successful. I think at the same time, the DoD is going to learn a lot. We talked this morning to Frank Delsing. A lot of the airworthiness and other tester involvement now, I think, will pay dividends down the road as we look towards how do we shorten time through experimentation for the Air Force testing requirements, and how do we close them on procurement and fielding of these vehicles. So I think the DoD has some really unique test capability at the ranges and facilities that we can leverage as part of this program to VTOL developers. So next chart here, I just wanted to touch on the overall team that we have for this Agility Prime integrated test team. It's really innovative. I think that we're getting all the way from folks like myself in the Air Force Research Lab to the folks in the Mobility Test and Aircraft Directorate with Terry Cross, who's our Agility Prime test manager, and folks getting involved from the test community, such as Tom Hill, the technical director for the 586 Test Squadron at Holloman Air Force Base, John Wilson, who's the deputy director, Emerging Technologies Combined Task Force at Edwards Air Force Base, and Dan Action Snyder is a major, the deputy division chief and test director for AFWERX Det 2 at Eglin Air Force Base. So a lot of expertise in testing that we think we can bring in to support these programs. I think it's been talked about a few times, the depth and breadth of test experience that the Air Force and DoD has. I think when we merge that together with a lot of these VTOL developers to solve some of these risks that they have and mitigate those, I think that we can do a lot to accelerate the work that's ongoing. So next chart here, I think these were mentioned, a few of these recent flight test successes. The XQ-58, developed by the Air Force Research Lab, was able to test a low-cost or attritable UAV, working with Yuma Proving Grounds with flight testing of that. The Agile Pod is a pretty unique program out of our Materials and Manufacturing Directorate at Air Force Research Lab. It's actually an open external pod that's able to integrate different kinds of systems onto aircraft rapidly and with an open architecture that's different than one done before. And was actually tested on a DC-3 aircraft, which is kind of shows what the potential applications to all kinds of different manned and unmanned systems. And Frank mentioned a few minutes ago the White Sands Missile Range Acoustic Research Complex, a fairly unique facility for gathering data on operating aircraft and using that in order to validate acoustic models that, in very similar way for the DoD as well as commercial VTOL companies, looking at what is the impact of noise on the environments, and looking at how do you model that. This kind of gives you that data to then validate those models. So I'm going to hand the baton over here to Terry Cross, who's going to talk about some of the experimentation and shifting from the vehicle development, working with the companies, to what the Air Force test needs are. Terry?
Thanks, Ryan. Hey, I am really excited to be partnered with you and AFRL on Agility Prime. In my role as a chief developmental tester in an acquisition program office, working a lot with Ms. Rutledge and some of the other divisions there to make sure we have tests planned appropriately with the right resources in there. I don't often get to work on programs in this kind of stage of development. I deal a lot with the two types of T&E on the right side of that slide, the DT&E and the OT&E, that evaluate those detailed, defined requirements of a typical program of record that Ms. Rutledge mentioned this morning. A lot of you heard Dr. Roper mention yesterday that in an Agility Prime, we don't want to develop a military unique vehicle for a predefined military mission. We'd rather take a commercially developed vehicle and see how we can apply it to a military mission. As we try to figure out how to creatively apply orbs in military missions, though, experimentation, that left side of the slide, is going to be important to really explore that potential of this new concept and the application to the warfighting concepts. That means we're going to have to appropriately tailor, as our Air Force Director of T&E encourages, the application of test and evaluation principles in a rapidly delivering this capability to the warfighter. I think that's really consistent with a lot of the points that General Lozano brought up as well. Another emphasis we have is to create these opportunities for rapid learning by executing small-scale tests to facilitate that system development. And that's what our test concept on the next slide is intended to illustrate. The first thing the Air Force wants to do with this test strategy is give companies the opportunity to further develop their concept vehicles and get the data they need to certify them for the commercial use. Ryan talked about some of our intentions there, and Frank Delsing mentioned that a lot earlier too. So we're offering these DoD test ranges and facilities for that purpose, but we also want to watch and learn as well. That's why our Air Force Operational Test Agency, AFWERX, comes in to look over the shoulder and do what we call an early operational assessment. And that's really useful, though, when it's informed by our user community. AFSOC is listed there as an example, but and you've also heard from General Miller yesterday about the interest in Air Mobility Command, and we've had interest from other services as well. So after we do those demonstrations, we expect the companies are going to continue with their certification efforts and the development of their vehicles for commercial use. But we also want to start looking at them for the potential military uses in an agile type environment. And that's where the experimentation phase comes in. This lets our developmental and operational testers, along with some operational users, start to evaluate different vehicles applied to various military missions. We'll tailor the DT&E that goes into that, but the objective is then to bring together those commercially developed vehicles with an understanding of the military application, so we can really go into fielding a system rapidly with tailored developmental testing and a robust operational T&E. So that's kind of our T&E flow in a nutshell. And I think Ryan has a couple other slides there to talk about how we're doing that with the partners that we have.
Right, thanks, Terry. So I wanted to zoom in a little bit. Terry's got the overall map for the program and how we're going to all work together and to integrate the demonstration phase as well as getting to this experimentation and the Air Force T&E requirements. But I think the Air Force Research Lab is really well suited as we look at this demonstration phase and have systems that have needs for maturing. I think that we can look at what the DoD resources we can leverage for this in-kind testing, use some of the agile Air Force Research Lab processes in order to support the program, and look at what the tailored support we can have for each of these companies. We understand that these companies are all at different levels of development, so we want to bring in the right level of support for those different systems and work with the partners. And also in Air Force Research Lab and DoD and the government, we have a lot of subject matter expertise that we can bring in. And I think that one of the goals of this program is to get testers and early operational assessment of these vehicles and better understanding, what their uses could be. And so getting them involved early would be very important in this demonstration phase as observers. So I think one of the things here that we're trying to do is bring in government participants right now. We talked about the Air Force Test Center support, AFWERX, getting operational users across the DoD, as well as working with NASA and FAA on urban air mobility and advanced air mobility efforts that are ongoing, and trying to look for ways we can work together on those. Terry, did you want us to talk about the second half of the chart real quickly?
Sure. I'll just mention a couple of things there about, obviously you heard from our contracting folks this morning and about how we're trying to leverage industry for that early adoption. Frank talked about the certification path we're doing. I'm looking at it from that acquisition, test management, and processes phase of it, and then we'll get into those our traditional Air Force Test Center and AFWERX for the developmental and operational testing. But we are really going to have to depend on the operational users to look at this differently, think a little bit innovatively, and try and bring all of those together to do those experiments, to do that learning as we go through here very quickly, so that we can get something fielded but tested appropriately into the field. Like General Lozano said, we want to be disciplined with our approach, because I think I like what he said about sometimes to go faster you have to tap the brakes a little bit, and we want to minimize where we have to do that by thinking ahead, so that we know what we can do, have that early discovery, and be able to adapt. Appreciate the words from General Lozano there. That's all I had.
Okay, thank you, Terry. I think I'll just go here to the chart here just to kind of talk about in a overall word cloud here some of the anticipated partner needs that we've had. We've had discussions in the government, discussions with potential partners and companies working on these vehicles. I think we've had some discussion here of flight testing and what the needs are. But I think that overall, the Air Force and the DoD can provide a lot of support of these companies, depending on where they are in their roadmaps to get to those commercial operations. We have experience doing test plan development. A lot of characteristics that I think that there's a lot of overlap between DoD and some of these VTOL systems, such as awareness of cyber concerns. And I think that's an area where we can do earlier assessment, kind of at a smaller scale, that prevents a lot of concerns later on that are harder to mitigate. Then looking at airworthiness, Frank Delsing talked earlier. And as well as I would suggest that there's a lot of ground test facilities that could potentially be leveraged as well. Across the DoD, the test ranges and ground tests or flight test ranges, there are a lot of utilization of these, but I think that, talking to these companies, and if they're ready to come in as partners to the DoD, we can look at how do we fit in the schedule, how do we, limit things to just the objectives that need to be done, and try to work with each of these assets, and can we leverage these resources to do testing to fit within the schedule that they're looking to bring these vehicles to market and try to accelerate us overall. So I'm looking forward to having those conversations, and I think that this is a really great program and exciting to see all the folks on the launch here.
Super. Thanks for the fantastic words there, the overview that you've given. Really appreciate all the great work that the test team has done. I want to go back to Brandon for some of the discussions and feedback from the audience. Brandon, what do we have? Another poll that's available here now?
Yeah. First of all, guys, thanks for sharing. It is fun to watch the audience increase over time, and the level of questions and interest in what you're talking about. It's fun to watch. So thank you. But let's open up two more elements here. One is a poll. I'll announce that poll quickly. We'll put it up on the screen. Oh, it's on the screen now. So this poll here is, except for the range and facilities, what should the government offer to accelerate development and fielding of this technology during experimentation and testing? Once again, you can vote with your phone by texting the number on the screen, or we're putting up on the links too where you can vote online. You can type that URL in. It's listed there too. I also want to make one other small announcement. In 25 minutes, the networking sessions are going to begin. You do have to register for those. I think they're open for 10 more minutes. So if you register for a networking session, we have over, I think, 500 people already registered, and we're using AI to make sure you're meeting people on the topic that you want to talk about and drive your work forward and drive Agility Prime and flying cars forward. So please register and join during that networking hour. Otherwise, Nate, over to you for our last awesome panel of the morning.
Super, thanks. So we'll go ahead and bring our test innovation panel, as we've called it, online. And as they're coming online, we will walk through some ideas, being able to use Agility Prime. Yesterday, we've talked kind of 3 different levels of Agility Prime. The idea that we need to compete with Agility Prime from a economic and national security perspective. The second piece, thinking about our processes, and the last, the product, the thing that we actually hope to get to the field. And we're going to focus on that process piece of it, because we have some fantastic innovators in the test community in particular that have been putting some thought into how might we test differently. And we really have to think differently given the fact that we're not testing to requirements. And to some degree, Agility Prime provides that sandbox to maybe think about testing a little bit differently. We talked at the beginning, again, the responsibility that we have to the operators, to the passengers. We intend to keep that same gold seal of approval on what we're doing with testing. But are there ways that we might be able to get to that end a little bit faster? And so what I'm going to do, I'll start with Sulu Hill to give some thoughts on how he sees testing into the future. And from there, I want to slowly go around to the other folks that we have online, testers that are doing this from an operational perspective, doing this from some of the emerging technology perspective, some of the rapid prototyping testing that's going on. So Sulu, over to you to kick it off. And then as we go to the others, a quick introduction from each of the individuals as well as their particular organization. So Sulu, thanks for joining us.
Hi, thanks for the opportunity. First of all, hello from New Mexico, and thank you for being here. To answer your question about how this could work is, I think there's an unprecedented opportunity here to advance technology for the effect of having a brand new set of operational outcomes. And the course to get there, I think, has to follow along essentially an unprecedented connection between the technology side and the operations side that we probably have talked about in the past, but haven't actually physically been able to put together. So this is an opportunity to do something like that. I think for this program goes, we have a pretty decent concept for why we're doing what we're doing. And when we probably have a pretty decent vector of what type of thing we want out the other end, but the whole how piece is the part that is the opportunity us in the T&E environment to figure out. And that space, I think, is the crux where we can merge together the ops and the tech side to really help bridge that valley of death.
Super, thanks, Sulu. I want to go over next to CB Kane. He is the commander out at Holloman Air Force Base to talk a little bit about some of the innovative testing that happens there at Holloman, different ways that Holloman might, not just for flight tests, but for some of the other test capabilities that are there, might be able to engage in some of the pieces of Agility Prime. We've even talked about White Sands, some of the early use cases, certainly on the test side, but on the early operational use side, how we might start to think about early operational testing in ways that, White Sands takes up a good part of New Mexico, how you might even think about eventually doing testing while you're maybe doing some interesting logistics work that helps out accelerate flight tests, actually using these vehicles in White Sands. Just just some ideas that have been thrown out. This is actually by some of our friends in AFWERX. So CB, over to you for your thoughts.
All right, Vidoff, thanks. And I'm just staring at some of the probably the most talented group of testers you have in this country, if not the world, right here. So what a great group of people to have work in this project. Many with recent and very prominent experience in this exact space of experimentation and prototyping. So out of the test group at Holloman, we've done a lot of work in this area. We're essentially, in many cases, the test execution arm for the Air Force Research Labs, for the Strategic Development Planning and Experimentation Office. We've executed light attack. We executed the Hellion low-cost, attritable swarm delivery platform. Space Internet, we connected on our C-12 to Starlink, the first DoD connection with the SpaceX Internet satellite. High power microwave and directed energy experimentation is ongoing right now with systems deployed overseas. Beyond that, best in world and most realistic navigation warfare testing. So think about GPS jamming, radar cross-section testing, early component live fire testing, and of course, the fastest place on Earth at the Holloman high-speed test track, where just last week we executed a hypersonic readiness test, preparing for high Mach weapons that are just right in the future. So I think this is not new to the Air Force Test Center, certainly not new to the AEDC and the 704 test group. We really think about those enduring principles of world-class risk management, tailored and adaptive test solutions, and then a relentless focus on the warfighter. As it comes to this particular program, Tom Hill has some really interesting ideas I think you should think through in terms of how do we separate safety of flight, that initial portion of getting the platform ready to go, and then from what you do with that platform, whether it's mission systems or autonomy or different control methods or different things you use it for or different operational use cases. If you're gonna have a manned platform, we're not gonna be able to shortcut the safety of flight and the airworthiness that goes with that. In fact, we don't want to, because nothing slows a program down faster than a mishap. So we wanna do that. But then once you've done that, if you can compartmentalize that portion of it, protect it in a way, I think you can move very, very fast with the systems that are used on that platform and get very quickly to operational use cases. So that's an overall philosophy. And we've seen work as we've explored our experimentation best practices. The second part of that is build in rapid iterative testing with testers involved early in the design process, if not build right into the design process, build the test. That's a principle of Agile and DevOps that I think you can apply here as well. Build tests in early, you'll reduce risk for the actual expensive and maybe not expensive, but the time critical testing. And you'll have more failures early, which is in fact what you want to do here. You're going to fail, right? Test doesn't create problems. It discovers the problems that are already there and helps you characterize them in a way so you can decide what to fix. You want to do that early when it's relatively inexpensive in the design process. So build into your approach an iterative design phase. Work up to those larger races or larger events with a series of very small, very focused iterative events that you can fix problems inside of those. I think that's what you want to do. And I think that's how you can fail. But by the time you get to the bigger events where people are probably more risk averse, you don't necessarily want to fail in public in a big way. You'll have failed in a small way to be successful there. I think those are the main things I want to talk about. You've got a world-class team here. It's really the people that are going to make this work. You've got a team that I'm staring at right here again that has that innovative mindset, that culture that we need to build across to the DoD that lets us design, test, and field these systems quickly. And Vidoff, you built a group here that's going to be able to do just that. So I'm excited to see what you want to do. White Sands Missile Range is a great place to test. We schedule and manage all Air Force tests on the range here out of the test group, and come and see us, and we can help you get there quickly. A lot of great resources, a lot of good weather, and 586th and team with Tom Sulu and led by Lieutenant Colonel Money Bookwalter can help you do that in a quick and effective and relatively inexpensive way. The other thing I'll just mention real quick is the airworthiness. If you can segment your airworthiness, you can be very, very successful. So the safety of flight portion, it requires a technical system rigor because you're going to put people's lives at risk. But from there, if you can build a bubble around the platform that says, okay, I can delegate airworthiness approval for different sensors, for different antennas, for different things you put on that platform, and I can delegate that to an appropriate level, there you can move relatively quickly. And we do that today with our C-12 and T-38 aircraft, and it makes us very, very successful, very agile, and very low cost as a test organization. So Vidoff, that's all I have. I'll turn it back over to you, and thanks for the opportunity to be here.
Excellent. Thanks a lot, CB. Next person I'll go to this notion of innovation. Former head on the Joint Staff Innovation Group and someone who's willing to get up at all hours of the morning just to see amazing things fly. Currently leading the DET 2 for our Air Force Operational Test and Evaluation Center, and closely tied into this effort and this technology now for some years. Tim Even-Stevens.
Hey, Nate, it's great to be a part of the Agility Prime effort. I do agree with you. My excitement about eVTOL has been alive for about, I'd say, at least 4 years from now. Once when I got the chance to review your thesis paperwork there at National Defense University, where you talked about this, and then when we got to get up and watch some of these vehicles fly, it's been fantastic. I will say from AFWERX perspective, what we're excited to bring to the Agility Prime effort is just over 600 experienced testers across many disciplines, multi-domains, not only the air domain and the air vehicles, but bringing the cyber expertise, the space expertise, modeling and simulation, some RF energy types of things. And really what we shine at is just managing it. We all know that flight tests and acquisitions is very much a team of teams approach, right? And we bring those different teams together. We've managed test efforts all over the world in multiple different ranges, organizations, different types of technology. And what I want AFWERX to be most known for from this community is, it resonated with me, Dr. Roper's concerns yesterday about investment companies that actually devalue companies that work with the government. We all know from years of discussion, small companies that just can't afford to get through the bureaucracy, the labyrinthian processes that some of our acquisitions brings to us. And I want the people online, especially our commercial industry partners, to just think, hey, AFWERX is kind of your bureaucracy insurgents. We want to be able to cut through all of that red tape for the developers so that we can get those systems testing with all the right, in all the right places, with all the right resources, with all the right experts involved, so that we can mature those platforms just as quickly as possible, both effectively, efficiently, and then obviously safely, as we've been talking about with airworthiness. So that would save obviously the developers time and money, and it's going to get the capability to the field faster. Just two examples of the myriad that I will mention from AFWERX standpoint is first and foremost our cyber security teams. The Air Force has been researching how to make airplanes and air gap platforms more cyber resilient for many years now. But we want to get involved. There's been a lot of discussion, General Lozano mentioned, about getting involved in test early. When we can get involved and our cyber analysts and experts involved early, we can actually help you bake in that architectural design from early on, instead of having to go and find vulnerabilities and the problems and then come up with clumsy bolt-on solutions at the end, which are going to cost a lot more. We'd like to see that design from a functional mission assurance standpoint just be powerful from the get-go. And also, AFWERX is working with many of the Air Force's DevSecOps software factories. We all know that the vehicles of today, any weapon system we have, very software-centric. So when these factories are producing and fielding software on a weekly basis, sometimes a daily basis, that very much changes how we have to be agile and adapt our test methodology so that we can keep up with that speed that they're dropping that software into these vehicles. AFWERX has definitely embraced the commitment to experimentation and innovation. We stood up a new experimentation office that is dedicated to this entire community. And the bottom line, I don't know if the slide that we have is a video to show with all of the panel here, but we have a culture of what we call adaptive relevant test, or the ART principles, which we follow 6 principles that really just focus on getting that capability to the field, getting the performance, the maturity of that system as quickly and as efficiently as possible, and then doing that at the most reduced cost, the most efficient way to save both the developer and the end user money on that standpoint. And I'll just leave with this. We live in a world of exponential accelerations in technology. And if we don't continue to evolve some of our test methodologies and try to keep up with that dynamic environment, then we're surely to be left behind. And we are excited to take this step with Agility Prime as we see the leaps you guys make. Thanks a lot.
Super, thanks even for that. I'm going to go over to Tom Maher, who I spent some time both in the large programs, KC-46. He's running the bomber programs that we have right now, to give a couple of comments, the comparisons of this that he's done both on the prototype testing as well as some of the large program testing. And in another minute or two, I'll let Frank wrap it up before we give General Lozano some closing comments.
All right, thanks, sir. Great to be here. So I want to, before everybody gets a little too excited about why they bring the bomber guy in, the requirements aren't getting out of control that fast. So no, it's still the air mobility program. But what we're looking to do in this is it kind of highlights from a testing and enterprise standpoint, we're looking at, let's get a wide variety across the spectrum of testers. So let's get a significant amount of background, whether it's from bombers, tankers, mobility, trainers, ET, small UAS, things like that. And the reason that is that we can collaborate on best practices, both on the actual software type thing and development we've seen in other platforms, as well as look at how do we take just the basics of flight test principles. So a lot of those things that we've all grown up and learned still apply. So our build approaches and config management and things like that will still be relevant as we partner with industry. And another thing that I want to kind of talk about is both that public-private partnership is where the government side can provide some good benefit to industry. And that provides our developmental testers, our operational testers, and our users a good feedback loop into industry in a rapid pace so that they can help improve their product in a quick manner. And that'll help in that aspect. So we've seen that with experimentation previously in light attack and other type of technology development things, whether it's weapons testing or navigation testing, things like that. So that's what we plan to bring with a wide variety of personnel in this program.
Thanks so much, Tom. Frank, over to you to wrap up the discussion here, and then we'll go back to General Lozano for final words on test.
I won't take too long. It was when I got on this program and started looking at it with a kind of tester's perspective, one of the interesting things to me was how many what we used to consider as military unique testing kind of capabilities actually applied to a system like this. So things like cyber, nobody wants an eVTOL platform flying through the city to be hacked. GPS denied or GPS spoofing. Well, if you've ever driven around a city, you know that the GPS is not that great. So you need a system that is not totally reliant on a GPS signal. Noise is something, like we mentioned earlier, we've got great noise testing capabilities. And it's just as important when you're flying these things around residential areas. Electromagnetic interference, electromagnetic compliance, that when you're running, 700 volts through a system, you got to start worrying about some of these EMI, EMC effects. So it's interesting to me to see that there's still a lot of overlap there. When it comes to early tester involvement, I do think that this is a revolution in the way that we can do tests. We can get out there, get early, start looking at modeling the way we might want to buy a fleet of these or employ a fleet of these. We can start looking at use cases early on in prototype phase where we can design what kind of use cases we want to use for these. Can start looking at just experimenting with different ways of employing these so that suddenly the requirements flow out of the test instead of tests flowing out of the requirements. It's a really kind of a new way to look at it. And really from a meta standpoint, we can also look at new ways of doing tests, so new test techniques on these kind of new revolutionary platforms. This is a unique opportunity for the test world simply because how often do you get something that is a completely revolutionary way of flying around and doing missions, and how often do we get a chance to get in there early and start influencing that? So I'm really excited to see where this leads, and the test pilot in me is jealous of all those guys that are still flying.
Super. Well, thanks a lot to Frank and to everyone else on the test team. General Lozano, there have been some questions come across the opportunities that you have across your various different locations. People very excited about that. Clearly, there's a huge breadth of experience and depth of experience. But I'd like to pass it off to you for some final thoughts, things that you've heard, and some words of wisdom that you can pass along to both us and the rest of the audience on how to approach testing of Agility Prime.
Well, Vidoff, thanks again for a chance to get together today with some really outstanding test professionals. And every time I listen to them, I learn something, and I'm inspired by them and what they're doing and their sacrifices. Somebody mentioned earlier, this is the fun part, and I could not agree more. This is why we've devoted our lives to this, because of the passion we have for capability development And Colonel Kane mentioned the enduring principles in the test center that include the risk management I talked about earlier, and having that agile, adaptable mindset, as well as that focus on the customer, the warfighter. And that's what gets us out of bed every morning and makes us excited to do what we do. I would like to make one comment. There is a strong need across the acquisition community to demonstrate greater agility, aggressiveness, smart innovation, and experimentation, and a mind for that. But when we say things like the test community needs to become more innovative and develop new practices, it presupposes that we're not already doing that. And there could be nothing further from the truth. In fact, you will not find a more innovative, creative group of people anywhere than you'll find in the test and evaluation community. So I did want to foot stomp that. And while we are thinking aggressively and we're thinking innovatively and with a great agile mindset, we also need to remember to remain true to the lessons that we have learned the hard way. And that's where that risk management piece becomes so very important. I like to say test is where our biggest dreams make contact with the physical world for the first time. And that's why getting the testers involved early and having that early discovery is so important. So I would encourage everybody to embrace that early discovery and to ask for that disconfirming evidence. Don't get caught in that trap of confirmation bias. Manage your risk relentlessly, trust your test teams, and things will go very well. We are in this together, the government, commercial industry, in the lab, and anybody that stands to benefit from this. We're in this together, and we're counting on all of you. So thanks again for an opportunity, and to the panel who spoke up today and talked about one of the subjects nearest and dearest to my heart. And great job to you, and thanks for your leadership, Nate, and to Dr. Roper also for his.
Excellent. Thanks so much, General Lozano. It is a thrill to work with those fantastic innovators across the test center, and looking forward to continuing to see some of the new ways and again, build on the lessons learned of the past. The chapel there at Edwards Air Force Base, if you look in the 1960s, that's not a place we want to return to at all. And I think we've got some opportunities with data and new approaches that we maybe can start pushing out, many new platforms in the approach that was done in the 1960s without the risk to human life. And that'll come from fantastic testers and the innovation that's happened through that. Thanks also to the contracting team and to the airworthiness discussion. Really appreciated that. And now I'll hand it back over to you, Brandon, to help finish us off for this morning hour.
Thanks, both of you. Excellent 2 hours. Just want to close out here with the poll that we did right before the last session, and test and evaluation expertise and airworthiness interaction are by far the leaders, as you can see on your screen right now. A couple other notes. Right after this, in 2 minutes, the networking session is going to start. We actually kept registration open because it was so popular. So many people are registering. So there are hundreds and hundreds of your colleagues waiting to use AI to engineer, bringing you guys together to make sure you can make the most out of the thousands of people that are joining us throughout this Agility Prime day and week, for that matter. After the networking session ends, we will be back broadcasting live here on this YouTube channel and agilityprime.com at 3 p.m. Eastern. We have one heck of a lineup for you this afternoon. Nate, do you want to preview that lineup, or should we send people to the website?
Well, I would definitely send people to the website, but we will say I will start off with NASA this afternoon with the Director for Aeronautics. We'll look at the work that's been done under the Department of Transportation with the FAA. We'll go through the innovative approaches to bring new people in with the Go Fly Prize. And then we'll talk at the end with the depth that Uber has had in looking at this market and the promise of that market. You're definitely going to want to tune in for everything we have here in a couple of hours after you enjoy networking with some of the new and exciting faces in this space.
Excellent. So to close this out, networking is up next right now. Check your email, check the links on the website, check the chat. We'll get you into the networking session. This afternoon, the lineup that Nate just talked about. Tomorrow morning, we've got a senator, and we're going to break a world record with the CEOs of many of the flying car industries. So stay tuned for lots more coming up next. But first, join the networking, and thanks for staying tuned for the last 2 hours.
Nice to be in orbit.
Discovery's 4 computers now have primary control of critical vehicle functions.
Welcome home, Columbia. Beautiful, beautiful.
Nice to be in orbit.
Discovery's 4 computers now have primary control of critical vehicle functions.
Welcome home, Columbia. Beautiful, beautiful.
Welcome back. 415 people registered for networking, 27 different rooms and topics, all interacting over this lunch break. Thanks so much for everybody participating. Already, we've got the numbers back up, and for this next session, we're going to go right into the action because we've got so many amazing speakers coming up. Once again, though, the Slack community, over 500 strong now. Come and talk with us in there. YouTube comments, please fill them in. We'll also be posting up polls and different surveys throughout the course of the next couple hours. Please join in the interactivity. We promise we'll integrate your ideas, questions, and thoughts into it as we live stream this whole afternoon. Nate, tell us what's in store for this afternoon, please.
Thanks, Brandon. We have an amazing lineup this afternoon. As you know, with Agility Prime, the Air Force just kind of getting involved in this, but we have really the pioneers who have been working for years, laying out roadmaps. So we have NASA starting us off. We'll go over to DOT with the work that they're doing. Then FAA, both from the unmanned aircraft system side, as well as the policy and certification innovation side. We'll then go to Gwen Leiter with a Go Fly Prize and hear some great stories about how you can inspire innovation in this sector with this prize event. And we'll over to the National Academy for Advanced Aerial Mobility Study with Peter Shannon. And then we'll finish off with Mark Moore giving the Uber vision of how this is going to happen today. Super event. We have 3 hours lined up. We'll have some nice breaks. We'll have some transitions with some of the surveys that are out there. We get some great videos that you get to see. These
Might
things
even be a virtual happy hour, I hear.
Indeed. It'll be 5 o'clock, at least on the East Coast here. So we'll be looking forward to that. So with that, we will just jump right in, and we'll begin first with our NASA counterparts. We have with us this afternoon Mr. Robert Pierce, the Associate Administrator for NASA's Aeronautics Research Mission Directorate. He manages the agency's aeronautics research portfolio and guides the strategic direction, including research and advanced air vehicle concepts, airspace operations and safety, integrated aviation systems, and the nurturing and development of transformative concepts for aviation, just like the ones that we're talking to today. So, Mr. Pierce, thanks so much for taking the time out of your busy day to join us. Looking forward to hearing the work that NASA has ongoing and opportunities for collaboration so it'll allow us to maybe bring these capabilities to market even sooner than expected. Over to you, Bob Pierce.
Okay, thank you so much.
I really want to say that I appreciate the opportunity to speak today. This is really an exciting topic. It's an exciting opportunity that we are all pursuing together. I mean, this really is an ecosystem approach, and so pleased that with the innovation and creativity that DoD is showing with its Agility Prime, and the opportunity for NASA to once again work with DoD as we have over the decades in various advanced concepts and advanced technologies. So at NASA, I think everybody knows, our role is to solve, technically challenging, thorny problems of flight, research, advanced technologies, develop advanced concepts, and do that in a way that allows them the results to be realized in operation, to be realized in the system. And so the only way to do that is to work in partnership with the community, with FAA, with DoD, with the industry, with academia, and everybody that it takes, standard setting committees and so forth, everybody it takes to really put all the pieces together to realize these exciting futures. So this area, that's encompassed by Agility Prime, we've come to call it advanced air mobility. And it really is one of those hard problems. When we look at it, it's essentially an entire aviation system that we have to put together. And obviously, we're going to be leveraging all of the knowledge and the infrastructure, especially the regulatory infrastructure that FAA has put together over years to really enable this to come to fruition as soon as possible. But that doesn't mean there's not a lot of very challenging issues that we have to take on, and it's more than just the eVTOL vehicles, as challenging as those might be, right? Because this is an ecosystem with a vision for in the commercial context, in the civil context, for on-demand urban and regional air mobility. And so if you think about what it takes to deliver mobility, there's a lot there. So as I said, the vehicle, the electric and increasingly automated, increasingly autonomous eVTOLs, advanced airspace operations and systems that'll be required, the ability to manage safety proactively and in time to resolve risks and hazards before they become incidents and accidents. And that's particularly when I think about the challenge, that one is particularly difficult. They don't have the long history of operations that we've had on the traditional commercial side. So we can't rely on that historical database to understand where the risks and where the hazards are in advance. So we need to be able to gather the data in real time, analyze that data, bring AI, bring ML, bring data analytics to the table, and make sure we are digging through that data as rapidly, as efficiently as possible to see where we might need to make some corrections. So that's a particularly difficult problem. Noise, right? We have to have acceptable noise profiles in the communities if this is going to be acceptable. So you think across all of that, and there's just dozens of really challenging problems that we're going to have to go after. And again, I think we need to do it as a community. These problems aren't solved individually because each one is interconnected. And so we have to be thinking across all of these issues as we move forward. And so, so how do we do that? How do we keep all of these issues at the forefront? How do we move the entire field forward so that we have a system that is maturing at the right rate in order to see it fielded and to see it in practice, right? So one of the things we are doing then is we're taking that approach, that ecosystem approach, and we're driving towards what we're calling a national campaign, what we used to call a grand challenge, right? But the idea is, if we can bring all of this together, the airspace, the vehicle, the safety systems, ability to do low noise profiles, all of that, if we can bring that together and show episodically every, and Davis Hackenberg was going to come right after me. We'll talk more about this, but if we can demonstrate every 18 months to 2 years, the advancements we're making in between those periods of time, bring them together in an integrated way and actually demonstrate through a campaign, a national campaign, in different locations, right? We'll use virtual means and so forth to bring traffic up, bring complex, scenarios up and so forth, and just show that we can actually do this. We can actually do the operations, the airspace operations, that the vehicle can perform the trajectories, that they can make the approaches and departures from vertiports, that we can handle safety issues as they arise and so forth, and continue to elevate the maturity and the complexity of our ability to do that. So at NASA, we're going to take that approach, those national campaign as a cornerstone. And then along the way, we're also going to be focusing really targeted ways at some of these hard problems. So we'll be focusing really hard on airspace integration. We've done a lot already with UAS traffic management, UTM, and now we can take that basic concept and apply this to this advanced air mobility area. We're going to focus on the in-time system-wide safety. So how do we do this? How do we assess information in real time and figure out where those risks and hazards are? Be focusing on noise, focusing on automation and autonomy. The system is going to need to be more highly automated when it matures. And so how do we make sure that functionality is there and that it's there in a very safe way? So those are some of the things that NASA is going to be bringing to the table. And what I'm really happy about is, with what DoD is doing here, this very creative, innovative approach that you guys are bringing to the table, we can partner with you. We can help, harness the innovation that's happening in the community, in the commercial sector, as well as with academia and others, and bring that together, and then also learn from you as well. See what kinds of operations you guys are able to support, and how that that learning could be also shared on the commercial side for commercial operations. So I think there's a lot of synergy there. Really look forward to continuing to follow and to have that dialogue and communication between the two of us, and over time find more substantive ways to partner as well. So again, want to thank you for the opportunity to say a few words today, and then my colleague here, Davis Hackenberg, will talk in a little bit more detail about the specifics of our plans and our investments and our path forward. So back to you.
Excellent. Thanks so much. It's been great to have, again, the foundation and the vision that NASA's provided. And I know one person that's really driven that is Davis Hackenberg. He is currently serving the NASA Aeronautics Research Commission Directorate as the project manager for the Advanced Air Mobility Project. He also serves as the Advanced Air Mobility Mission Manager for ARMD. He performs duties from NASA headquarters in Washington, D.C. His project duties include the development, implementation of the mission, spanning all the relevant projects in the center, with the goal of implementing the NASA investment strategy in a manner that accelerates this future of air mobility. Davis, thanks for being such a great partner as we've gone along. Thanks for joining us here, and looking forward to hearing some of the detailed things that you've started outlining. I know you were all a victim, much like us, of COVID in your early launches. I think you were a little quicker in getting to it. So again, we'll follow your lead and appreciate hearing some of the words here.
Yeah, thanks, Nathan. First, thanks to Bob too. Bob, good introduction. Yeah, thank you guys for inviting us to this and giving us an opportunity to speak here. A few words about the Agility Prime team before we get started on the NASA stuff. Actually, Nathan, I met you about a year ago now. But it was really about 8 months ago that you started talking to me about Agility Prime, and kind of came with some urgency. Hey, we're gonna do this, and you have been such an impressive team over there with how fast you've been able to launch things. This workshop specifically, I mean, it wasn't too long ago that you started talking to us about lessons learned from our virtual kickoffs and planning and such, and you guys pulled this together really fast and extremely well done so far. That same kudos carries over to our work together on our partnership development. when we started about 8 months ago talking about Agility Prime, we were talking about national campaign and our aeronautics research mission director at mission strategy for AAM. And you guys have picked up so much so quick. You know the things we've been working on. I'm working on pilots and automation partnerships with you guys, working on your Agility Prime effort overall, and making sure we were synchronized with national campaign. I think we as a team have done really well, and I think it should be exciting to the whole ecosystem out there how well the government and with the FAA coming up in the next couple of briefs, how synchronized DoD, NASA, and the FAA have been over just this last year on urban air mobility, really. But going all the way back to 2011 timeframe, I remember we were working sense and avoid, detect and avoid together. We progressed across the federal agencies, working things like UTM and small UAS integration together. And I've just seen so much progress and so many good synergies. Specific to urban air mobility, advanced air mobility, and just the synergies real quick. I really think it's great how, and it's really motivating everybody how the military can come out and you guys have this carrot of actually buying vehicles and using these for their actual intent, eVTOLs and in theater and logistical situations and stuff, and it complements what NASA tries to do really, really well, which is more the commercial aspect, passenger carrying or cargo carrying in a commercial aspect for us, and then so you take the lead on that vehicle development side and use it, and we can help with airspace integration, the commercialization, and then we always look a little bit longer term to things like scalability. So that leads to my next slide. So if you could progress to slide 2 on my slides. I can't actually see that the slides are up right now, Nathan. Can you confirm that for me?
I can confirm that the slides are up. Yep.
You're up and running.
Yeah, thank you. So, so on the second slide here, we talk about our advanced air mobility mission and what it entails. Really, what we're talking about when we say advanced air mobility are those transformational concepts, electric vertical takeoff and landing for local and intra-regional missions. Now, the urban air mobility component of that is really the local part. For the most part, some of these eVTOLs though can go 150 miles and could be intra-regional. They could go, between Philly and New York is a good example, for instance. Urban air mobility is the #1 mission within advanced air mobility. We just don't want to limit it to just urban. As we progress through our mission planning and our technical research areas, we realized that just urban wasn't the only answer. It's the highest demand, the most complicated area where we were going to put our focus. And I think where Agility Prime, is trying to leverage the industry focus on their goal for urban air mobility, those vehicle configurations. But yeah, so we use the term advanced air mobility now to just make sure it's broad enough, but we still have that urban air mobility focus, and we still refer a lot to these UAM maturity levels that we talk about. So I'll use this mission diagram to kind of talk about those and talk about that progression. Right now, the industries, we say they're at a UAM maturity level 1. So they're building conforming prototypes. We're working the ConOps for how all of this is going to work out. And people are starting to work with the FAA, and the FAA is talking to us, and the industry people are talking to NASA and Agility Prime. And we see real likelihood that some of these eVTOL configurations will be certified in the, let's just call it 2023 timeframe. Some of the leaders are fairly close to that time frame, maybe could even beat it. And when we get those certified vehicles, we start to get into our UML2. So we start being able to talk about commercial operations, actually moving cargo, actually moving people around. Probably won't be in the most complicated of scenarios. It'll probably be more like piloted VFR type of missions, using today's NASA and today's infrastructure to progress through some of these early missions. But as we move forward, NASA's research really starts to come into play. As we move to a UML3, we start talking about a complexity increase. So we go from this UML2, low density, low complexity, VFR types of operations, to this UML3, where you really start to need to interface with today's airspace systems, but also develop and progress the airspace management system and your airspace integration farther along, so that you can operate efficiently. You could go into urban cores one thing we talk about with this UAM maturity level 3 is using today's infrastructure more or less. So you might have something like 20 vertiports in a city operating these vehicles at some reasonable cadence, so that you have more or less simultaneous takeoff and landings, operating across these vertiports, actually moving people. Your automation starts to need to increase when you get into these more complex operating environments, like an urban downtown or a more integrated airport environment or something. And then as that progresses and you get that complexity down and you get the public trust and you know that the vehicles are really something that's accepted by the community, the operational models, the pilots are, you have safety technologies that are aiding your pilots, you're able to move into this higher density UML4 that we talk about. With that higher density, you start to need a lot of things that NASA is working on, or NASA is not working on, and NASA is working on. Things like manufacturing and supply chain, things that we dabble in, but the military is really, really excellent on. So as Agility Prime gets involved with vehicles and we progress through this progression, and NASA brings this research on airspace integration and on automation and other technologies, the military will be able to help the whole ecosystem with things like supply chain, manufacturing, ground operations, maintenance, things that you guys have a wealth of expertise in. So partnering with the military versus partnering with NASA could have, multiple different types of benefits as we progress through this system. One thing I like to say about this UML4 is it'll be the time where I get to fly to work. So we've done some market studies on this, and essentially when you get to UML4, you're starting to look like a more scalable system. You get to this medium density, there's enough of the vehicles being built and the operational cadence is fast enough that the price point for urban air mobility, a ride to work, should go down to something that is affordable to somebody like me that's, a government employee, for instance, a middle-class person. Or if I was in need, I wanted to get from an airport to to my meeting downtown, or maybe even from home to my meeting downtown, I could actually go spend that 40 or 50 bucks and fly to work. So with that, please advance to the next slide. Moving to the next slide, we'll talk about what NASA's actually working on now. Bob started to allude to, we take this ecosystem approach. So we're not just focused on the vehicles. We're focused on the vehicles, which you see in red on this slide. We're focused on the airspace systems and integration, which you see in blue on this slide. And we also have elements of our research that's focused on local communities and what we're going to do to aid them. So when I think about Agility Prime, I don't want to speak for Agility Prime or limit them too much, but what you guys are doing in the military is really that pillar 1 and pillar 2 stuff you see down there, those vehicles, building safe, reliable, quiet vehicles, and then the automation that goes with the pilots. The military and Agility Prime really have a great skill set and focus there. You're less interested, I would say, probably in the commercialization, which gets you into all of the attributes you need to advance through these UAM maturity levels with respect to airspace integration. So we've worked with the military on UTM before. They do it with a little bit different slant than we do. We do it with a look at how we get the operators to use it and how we integrate it into the FAA for air traffic management purposes and stuff. And we'll continue that type of research as we move into our robust AAM portfolio. So we'll continue to build out UTM and UTM inspired concepts so that we have the next generation airspace management systems out there. We'll look at infrastructures, architectures that are necessary to really advance automation and advance communications, navigation, surveillance, information type of transformations, procedures to fly into vertiports, complex vertiport environments across the cities, and then all the airspace services that'll be necessary to really enable this. I think a simple example that a lot of people would use is, it's probably not ideal as we get into automated aircraft that we still need to constantly be in communication with air traffic control. That's a pretty tough requirement that we think someday we can integrate a next generation air transportation system that'll have automation there and digital elements to that air traffic control communication. And then Bob mentioned that in time, system-wide safety management element. With our national campaign efforts, we're gonna work the operational components of this. So we're gonna look at operational integration, operational safety, and how all of the vehicles, the airspace systems, and those technologies come together to provide a safe operating environment as this UAM progresses. and becomes more of a reality of the world. We're also going to leverage that national campaign for data and things like public acceptance, partnering with ecosystem or with localities, municipalities that will do testing, bring people, talk to us about noise regulations, and help us come up with acceptable metrics for noise and the human response to it, not just from an individual vehicle, but from a whole fleet of vehicles that could potentially be operating in your area soon, nearby to your home, where it's a constant visual and noise of urban air mobility eVTOL configurations. Yeah, so with that, really robust portfolio we have some common partners definitely already, and we're really excited to keep working with Agility Prime and this community. And hopefully you've, little plug for our ecosystem working groups. Hopefully you've heard about NASA's ecosystem working groups, where we're bringing people together similar to what Agility Prime's doing here today to give us feedback on our portfolio and talk to us about the future and what your needs are, and help integrate this whole ecosystem beyond just the eVTOL providers, and make sure that we progress as a community together. And like Bob said, try to raise the water level for everybody to really make urban air mobility a reality within the next decade, we hope. So that's all I have, Nathan.
Super. Yeah, thanks a lot for that, Davis. Several questions that are starting to roll in. What do you see? I think NASA has probably done the best job of laying out what this roadmap looks like. In your opinion, and from what your team has started to see, where do you see the biggest technical hurdles?
Yeah, I mean, it's some of them are cliche to say, right? But infrastructure is one for sure. I mean, the timelines for power grid and building vertiports and stuff to really enable this is one that's going to take some time. Automation is without a doubt, right? I mean, you could look at just those UML2 operations. Simplified vehicle operations is something that I assume Mark Moore will talk about in a little while. But just those SVO concepts, leveraging simplified flight controls, and how they progress into automation. Automation is it's almost the impossible challenge. I've said publicly before that I'm dedicated to as much as we can do at NASA to make this a reality and work those automation technologies, make them happen. We're all in there. We're all in there, and we're gonna do everything we can to partner with everybody that's investing in it and bring as much of that to the table as possible. And don't you talked about a race to certification yesterday. Don't downplay just simple certification of these vehicles. Like I said, 2022, 2023. I do think that those timelines will happen, but man, it's not going to be easy. Electric propulsion is really, really, really hard. And there's going to be test failures. There's going to be fires. There's going to be things we have to deal with just to get to that. And then probably my number one and NASA's number one is the airspace integration problem. It's just look at the drone industry, right? They had an ARC in 2009 talking about small UAS integration. Multiple ARCs since then, advisory committees and such. Airspace integration is really, really tough. We have the safest air transportation system in the world today, and the FAA should not compromise that. And it's not easy to get around and just segregate yourself from that air transportation system. And so airspace integration is going to be one of the most difficult challenges. And the UML approach and the industry approach right now, progressing through those piloted operations, is the most straightforward way to tackle that. But to get the profitability and scalability, we're going to have to do a lot in that area.
If I could just add to that, Davis, I think one thing that always strikes me is I think it's the intersection of, the technical and the societal, and in that area, it's safety and noise are going to be, and you referred to some of these, Davis, but I just think it's going to be hard to say exactly where the solution is, right? Because it's really dependent on what's acceptable to the communities that are out there, and that's going to be a process that is both, involves our researchers and what we can do, what's the art of the possible, but then it's how do we involve the communities in this in a really fundamental way, because this is a system that's going to be much more intimate to an urban community than the traditional aviation system. So how do we manage that? That's going to be really really challenging part of this.
So, sir, that's a great opportunity to go into the next question. As you look around the virtual room, are you encouraged or discouraged about working across interagency to create an environment for the technology to grow?
I'm really encouraged. I mean, the FAA is, you know, they'll talk about it, but just the changes in their organization over the past five to 10 years, five for sure, has been just tremendous. They are so forward leaning now. And I have a history with the military working things like detect and avoid and small UAS. And I know how much they can bring to the table as a potential paying customer, and just the smarts that the military has and the experience that you have in operations. I'm really encouraged by it. The very first thing I said when, to my team when Nathan showed up was, the more the merrier. It's all good. Bring it. Like, let's get everybody working the problem. This is a hard problem. You need everybody on it.
Absolutely. Great.
I would say too that there's right now we have what's called a UAS XCOM, which has all the agencies you can think of, DHS and DOJ and FAA and DOD and NASA and Interior, and they've come together to work the UAS problem, and so that's an opportunity to build on that for this problem space as well. So I think there's a good opportunity to continue the momentum we've built there.
I think that's a great point, actually. Do you see something like the UAS XCOM, or maybe that body in particular? Is there additional work that needs to be done to do this structurally, or do you feel like we can continue to do this through the collaboration structures and methods that we have right now?
I think overall we could use it. We could use the US XCOM structure and that we have. In fact, at the next XCOM meeting, which is coming up in just a few weeks, we will have a few minutes, an opportunity to spend a few minutes talking about this area with them to start teeing this up. Because I think the other challenge, right, is one of, if we're going to do this system is going to have to be secure, and we don't want it posing risks to critical infrastructure and so forth. And so getting some of these agencies spooled up now and starting to understand what the challenges might be and working them is going to be important. And I think that infrastructure of the UAS XCOM and the opportunity to start having the conversation will help.
Great. How do you see the roles of NASA, FAA, DOT, and DOD?
Well, I mean, I guess from my perspective, DOT certainly has a lot of policy authority, so they can certainly do a lot to support the policy process. FAA is just fundamental in terms of the details of the regulatory environment, the standards, the ability to get operational approvals, all of that, and that's why they're such a great partner for us, for NASA, and we work, with both DoD and FAA for decades, and I think with the FAA we've found an approach, actually relying on the next gen air traffic management system that's been developed. We've really developed an approach to working with the FAA that's been very effective, and we are now extending that to what we're doing here, as well as the work we've done with them on UAS as well. So much good work has gone into that FAA relationship is really solid, and we can support their role as well as help to bridge to industry. And then with DoD, just what's happening here is just incredible. The opportunity that's being created to accelerate technology development and deployment, and then take those lessons and bring them to the commercial sector is I think it's fantastic.
Just to follow up, how does NASA envision Agility Prime and the AAM program coordinating in the future? Are they fulfilling separate roles within the ecosystem?
Davis, why don't you take that? You spent more time with the Agility folks, and
yeah, I don't think we, I look at our roles as, sure, they're complementary and there's different areas that we'll focus on, but I think we have, especially over the last 8 months, I mean, Nathan and I are on the phone any time of day, and out our strategic direction, where we're headed. I mean, we've started drafting an agreement to talk about how we're going to do things like model-based systems engineering together across our portfolios to come up with the right architectures that are going to satisfy the military's vehicle needs, the commercial needs of the eVTOL community, and then you know, the airspace integration elements of it too. I mean, I think the DoD has excellent resources and capabilities across the military test ranges, everything. We have some of the same. I think we're extremely complementary to each other, and I see this being a really, really close partnership for a pretty long time. Hopefully not too long, right? But probably pretty long.
Yeah, and I certainly would echo all of that, and again, appreciate being able to use NASA and all the great work to help us learn quickly on this. One of the things you mentioned, model-based systems engineering and some of the work that the NASA team has done. For us, there's been some discussion of using Agility Prime really as a pathfinder for a series of our different processes and ways of kind of doing some experimentation on processes to some degree with this Agility Prime project. How do you see that working with model-based systems engineering in the cases that you've run so far, going into the future with MBSE in particular? And then what other types of technologies out there or processes out there might you use this approach for eVTOL AM to kind of prototype or to do process improvement?
You're not throwing me a softball there, are you? No, that's a great question. I think, you know, as you're going to come in with different partners than we're going to have. Some of them are going to be the same. You know, you've referenced a few of your partners already. But as we look at model-based systems engineering and the overall architectures, the inputs and outputs of that system, we're going to be able to complement each other and look across what you have and what we have, and to see what needs to make it into the regulatory environment, what needs to be standardized, and we can leverage across our full ecosystem. So lots of that. Other areas that, you know, I think just the common test infrastructure type things that we're going to do, we're going to work on across the two different sets of national campaign flight activities, and what you guys do in Agility Prime, how we collect data, how we aggregate those databases and use the very minimal opportunities we have to gather flight data here. And I know that, you know, Bob mentioned the long history of aviation, right? We're talking about half-hour, 45-minute flights here and now, and we've got a good 1 million flight hours, right? So we're going to have to come up with common ways to leverage every flight across this whole ecosystem, across every VTOL, to use as a means to learn about safety and lessons learned and everything. And we need to find ways. It's going to be challenging. We're going to need to find ways to share those lessons learned across each other, and then, you know, other federal government orgs, especially the FAA. And it's going to create a lot of challenges with the XCOM and everything. I think we have a lot of the right types of coordination things in place, but it's not going to be simple. It's going to be a lot of work.
Absolutely. Sir, may I ask, when do you think you will take your first flight?
That's the question we're not supposed to answer. My first flight, like, is it a test flight, or is it because I'm going to weasel my way into a test flight before all this is done? 2024. I'll get on one. 2024. See what Jovi has to say about that.
Bob, did you have any idea? Are you going to weasel yourself onto a flight?
I'm going after Davis. That's all I have to say. When he comes back and tells me that it was a good ride and everything else, then I'll get on after him. So
have an acceptability first, huh?
Exactly. Yeah, you gotta sum that subject up.
Super. One last question in terms of as we're looking forward to this, what do you see? You talked about kind of the interagency challenges. What do you see is some of the hurdles? Are there new ways of kind of looking at bureaucracy here? I think you've certainly given a vision that shows that we're working together. What hurdles do you see moving forward? You know, we're kind of in the early stages of this. Are there things that could be done that might mitigate that as we're going down the road?
Yeah, well, honestly, one of the biggest ones that I would answer, you guys, I know you guys are tackling directly, so I'm not, you know, answering this because of that, but the supply chain and security. I mean, those two are just, I mentioned supply chain earlier, I didn't bring up security, but those are things that, you know, when you're talking some of the vehicles and the early operations, they're out there and they're really easy to ignore. But they are really showstoppers. I mean, they can stop this whole thing dead in its tracks before we ever get to scalability. So those are, I don't know, they're even a little cliche to say, but they're real. I mean, supply chain and security are so real and they're so hard. There's no crystal ball on any of them. Everything's going to advance and progress, and that'd be my theory that I'd say.
Yeah, I mean, I guess I reflect on there are certainly challenges. I mean, you know, government doesn't necessarily move quickly, and this industry, you know, it's particularly innovative and wants to move rapidly, and so I think we're learning how to move more rapidly, but to a certain extent, I think it's probably good to have a little bit of that balance, you know, to make sure that we're doing things right. You know, I mean, Davis mentioned a couple things that could creep up and bite us, but there's a number of things, and so I think we do have to do things right. But I mean, within NASA, I think we're trying to be as agile as possible. I mean, as Davis said, I would second it. I would applaud how agile the FAA has shown themselves to be, and really trying to take a forward-leaning approach relative to how, you know, using industry consensus standards as a means of compliance, things like that I think will help things go much faster. So I think all the mechanisms are there. We just, and you know, obviously what you guys are doing with Agility Prime. So, I mean, I think all the mechanisms are there. You know, we just have to be ready to, you know, and willing to use them. You know, and that's often the biggest hurdle, right? Is overcoming the, you know, that culture. Oftentimes a risk-averse culture to taking a chance, taking risks within our own processes. So, but I think my observation is we generally have the flexibility if we want to apply it.
Super. And that was not actually, I didn't pay Davis to make a plug for our Thursday afternoon sessions. We both have PK from NASA who will be speaking to that very difficult challenge of supply chain. We also have some of our test team talking about how you bake some of the cybersecurity pieces in right from the outset. So as you said, those are massive problems, but I think we've got some massive brains, some brilliant folks working between our organizations that I think can really make some forward progress on that. So give you some final comments here, and many thanks for joining us. Any last parting thoughts there?
Nothing here. Just thank you guys for everything you've done. And again, just extremely impressed with what you put on here over the past 2 days so far. So keep it going, and I'll keep listening over the next few.
Yeah, and I second that. I think really applaud what you are doing. And I just think this area is ripe for innovation and possibility, and I think it's really going to bring so much economic potential and you know to the nation, as well as some excitement. And I think right now both of those things I think are needed. So yeah, as David said, keep it going, and let's all stay together in partnership and get the job done.
Fantastic. Well, thanks so much to you, to your amazing teams who've been helping us along. And we are very much looking forward to moving forward with you together. Brandon, I think you've got another poll for us here.
Yeah, us and the team behind the scenes here, we of course are listening to what you guys are sharing, and we can't ignore that the question was asked, what year will you take your first orb flight? The presenters obviously gave the answer, but let's give the audience, I think it's over 1,000 right now. Let's give the audience a test to see which year will you take your first orb flight. Once again, you can text in your answer using the instructions on the screen. We'll also put the link in Slack and in the YouTube chat, so you can just click and decide. And we'll post those results after our next briefing, which, Nate, back over to you to introduce our next speakers.
Super. We have the fantastic opportunity of having this afternoon Finch Fulton, the Deputy Assistant Secretary for Transportation Policy. He served as a member of the President's transition team, focusing on transportation and infrastructure policy, and with the Department of Transportation as a special advisor to the Secretary of Transportation Policy. He served in the House of Representatives under Congressman Jim McCreary and Congressman John Fleming from Maryland. He also served with Senator Jeff Sessions. In addition, he's worked in public affairs at Vox Global, devising and executing integrated policy and advocacy campaigns. Very, very appreciative of the Department of Transportation, and in particular for Secretary Chow and her remarks yesterday. With that, Finch, hand it over to you, and thank you for joining us.
Well, terrific, and I appreciate it, and I appreciate the opportunity to be here with you all. So as he said, my name is Finch Fulton. I'm the nominee for Assistant Secretary of Transportation for Policy. And among some of the more interesting work I get to do at the department, I manage the Non-Traditional and Emerging Transportation Technology Council, or the NET Council at the department. So one of the things we've been focusing on right now in our current situation is how we can use these innovative transportation technologies to provide a public service to people, and how we can enable the ecosystem of innovators to play their role. We've had some initial successes. A few months ago, before any of this happened, the department granted the first ever exemption for a passengerless delivery vehicle, the Neuro vehicles, to be able to get on the road for testing and research purposes. So we've enabled 5,000 of these vehicles to be on the road. And what we've seen so far is California has already started granting permits for these vehicles to go out. So they've got operations going on in California, operations going on in Houston. And as we look at a safer way to deliver goods, one of the things that we're seeing being proven out is these low-speed passengerless delivery vehicles being out and on the road. So we hope to gather this information and update our regulations for that. Another use case that we've seen are these low-speed shuttles and automated vehicles that are still in the testing and development phases, being able to be sending medical tests and supplies back and forth between off-site locations to medical facilities back and forth. This is also giving us some pretty good information that will help us going forward. And what we're seeing is a lot of the innovators in that space. One, our acting administrator, James Owens, put out a call for innovators to come to NHTSA and let us know what we need to do to remove any barriers to these operations. And automated vehicle developers that haven't been thinking about this are now gearing their operations to be able to support these sort of services. We're seeing this with automated vehicle trucking, the low-speed shuttles, rideshare services, and the like. In addition, we're seeing drones being used by public responders and public safety officers in a number of places around the country. One case in particular that stood out to me is in Chula Vista, California, where they're using drones to be able to reach out to a homeless population that lives in a canyon. And it usually takes 2 to 3 days to get out to them, make sure they have supplies they need to keep them safe, make sure that they have personal protective equipment, and then just make sure they have, understand when a service is being provided in a location they can walk to. So what usually took 2 to 3 days took about 2-3 hours, and you saw the same amount of reaction, people coming to get some of the safety supplies that they needed in a way that hasn't been utilized before. We're also seeing actual drone deliveries taking off around the country, particularly in Nevada, Virginia, North Carolina, and Florida, both through programs, the Drone Integration Pilot Program, and from partners that weren't necessarily part of that program around the country. And so these are ways that medical devices are being delivered directly to people that need them on a limited basis right now, but we are seeing actual operations happening in America right now in response to the current coronavirus situation. So as we approach these innovative technologies, and as the department looks to engage throughout the federal government, one of the things we've done recently, taking lessons learned from our engagements with our national security partners on drone operations around the country, with automated vehicles. We recently had an initiative where we put out a guidance document back in January called Automated Vehicles 4.0, Ensuring American Leadership in Automated Vehicle Technologies. And the key point for this group is what we're doing as a department is ensuring that we're engaging proactively with our national security partners to ensure that we're fleshing out the security concerns, the safety concerns, the privacy concerns that they have, so that they are proactively thinking about these things before we get to a rulemaking where they can hold things up because we haven't addressed their concerns. And to be frank, we lost a few years of regulatory progress with drones because we did not take these actions years in the past. So those are lessons learned, and making sure that we're engaging with the innovators and engaging with our security partners around the country. So what I'm excited about is seeing with the work the Air Force is doing today, gathering all of you, the innovators, the people that are actually creating the technology, and then the policymakers and the security partners together, so that we can be thinking about the next wave of aviation. So whether they're called flying cars, UAM, air taxis, eVTOLs, orbs, which I had never heard before this last week. The idea of advanced air mobility is novel, but it also takes histories and lessons from the past. And the whole point is that we move people safer, more efficiently, more cost effectively around the country. And it's more than just being cool, which it is cool, and I'm super excited to work on it. So I'm very thankful to be here. But it's also important as we face nationwide transportation problems around rural access, around congestion around the cities, around delivery of goods, and most of all about safety. Because what we know is the current safety situation of our nation's transportation system is unacceptable. So I give full credit to the Air Force for working and all the work they've done with the Agility Prime Initiative. You've seen and heard some of the use cases yesterday and today, and you'll hear more coming up tomorrow. Thinking through the use cases, what the Air Force is thinking, and what this can mean for the commercial sector, and the great overlap that there is. As we've seen in other areas, why shouldn't we be able to use these military developments to bring them together in the commercial sector, make sure we have those lessons learned around safety, security, cybersecurity, things like that. I think it's terrific. But the bottom line is, as we're looking to move things more efficiently around our nation, hearing from you all is critically important. And one of the things I've already heard and that I take from this is the horror that people have at the bureaucracy that can exist in government and has existed and to some extent continues to exist, and what this means for their work and the things they want to do and how they want to innovate. And I'm with you. One of the main reasons I got my job at the department is because I got really good at criticizing the FAA, specifically about things I thought they could do better. But it's been great because the FAA has been listening. They've been innovating. They've been adopting their approaches, whether because they're listening to the guidance of Secretary Chow and her vision, or with Dan Elwell, who's been there for a number of years, or Steve Dickinson, who's brought some of his new expertise. I do think we're seeing a more proactive footing and engagements from the FAA, maybe built on the success of the drone integration pilot program, which has hit its third year and enabled first in the world complex operations for drones, but also in the interagency partnership that is developed. And so I think it's terrific, and we're trying to take those lessons learned and incorporate them throughout the department. And again, one of the things I think is interesting as the manager of the Net Council, I heard some of the previous conversations about what it means when you're starting to tie these UAMs, the AAMs, the orbs into the actual transportation system. What does that mean if you want to actually connect to the public transportation systems? What does it mean if you want to connect to light rail? How can we support? What do we need to adapt? What regulations do we need to be thinking about? We're having those discussions today at the department through the Net Council. The FAA has been great working with us and talking with us. But I think there is a lot more we can be doing to ensure the safety of these systems going forward as we look to connect the multimodal connections for these systems. And this is Secretary Chow's main message. We can't, I hear all the talk and I'm all about it. When will we be able to fly in these vehicles? What's the year? And just ensure I stay on message. The answer is, of course, when they're safe. And so that's why the safety approach is so critical to us. And that's what's so exciting to me about what the Air Force is doing and engaging with the innovators, saying, you have this cool concept. We want to take it from this cool concept, put our money behind it, our expertise behind it, our time behind it. We want to make it happen here in America. We want to take this from a cool idea to a proven design and something that can operate in the future of Americans' aviation ecosystem. We want to create those pathways, which I think is just tremendous. But I do hear the angel on my shoulder safety that is the FAA, and I understand them a lot better than I did a few years ago before I joined the administration. We're going to have to work together on things, whether how we reach airworthiness, how we ensure we have redundancy among the mechanical, electrical, software, fireproofing, and so on. I know that Mike Romanowski is going to be coming on later, and he can go into the details on a lot of those issues. But does it play well with others? We're going to be having to share this airspace. Can you navigate through some of these urban canyons that radar can't necessarily pierce? how do you avoid other types of aircrafts? So I know that the FAA recently posted their updated UAS traffic management system back in March with the concept of and what it looks like, and you should definitely go to their website to check it out. I know we're already looking at an update going forward. So we are trying to work proactively with you on these problems, but it's something that, ultimately we're going to have to figure out how to do together. But questions about who's flying it, what type of operations are they expected to do, what sort of training do they go into? I joke because as we look at automated vehicles, our main authorities at the Department of Transportation is mostly on what does a new vehicle look like and how do you set a certification for a new vehicle as it's sold into a system. That's really it. The operations are handled at different levels of government, which makes sense if you're talking about speed limits in a neighborhood and things like that. With the FAA, it's completely different. The aviation is always considered something big and scary and something that they want someone else to handle. And so the FAA has to handle everything from the types of operations that can happen, the vehicles they can happen in, time, day, and place, and manner type restrictions, who can maintain it, things like that. It's just such a breadth of responsibility that they have. I have learned to respect it more. But we will be looking to proactively work with you and engage you on these issues, on things like the infrastructure, on things like societal acceptance, on things like noise and safety, the things that I heard brought up in the last panel. I think that's important, but also we have other authorities outside of the FAA that we want to make sure people are aware of far in advance of needing to engage with us. Things like economic licensing, ownership and control, competition, and access issues. These are things that the department is required to mandate, to put mandates forward on and to promulgate rulemakings on, to use my government words. But these are things that we want to make sure that you're aware of and know when and how to engage with us. And we want to be proactive and responsible partners in that. So I don't say any of this to discourage anybody. There's a lot of work to do, but we're going to be doing it together. I'm excited about the work. There's probably no more interesting work you can be doing in transportation for sure, but certainly in the government. So we're thrilled to be able to be here today, thrilled to work with you on, thrilled to continue to hear from you as to what you're thinking about the government needs to be doing, how you're approaching these systems, and how you're approaching safety. So, Colonel Diller, I'm thrilled to be here, and don't know if there are any questions. I think we have a few minutes before I get kicked off the stage, but.
Absolutely. Finch, thanks so much. Really appreciate the opportunity. One of the questions I think, I know you've been put a lot of time into, but just give a little bit of clarity. When we talk about infrastructure in this sector, two questions. First, what all do you include under the purview of infrastructure? And then secondly, like supply chain infrastructure is a really hard problem. What do you see as a path to start to capitalize infrastructure in a way that meets the timelines that we're seeing with this technology right now, that will actually allow it to come to a field and provide the market value that is suggested?
Well, infrastructure can mean a few different things, at least in the way we talk about it at the department. On one hand, you have things like the multimodal transit stations. If you hear the vision of, for example, having these operations in mass by the 2028 Olympics in Los Angeles, which is a great goal to mobilize around for the widespread deployment and usage, you're thinking about the infrastructure to actually land and take off from a public transit point of view to enable these operations by 2028. In some ways, that is simpler than the complex questions that you get with UAM or with weather control, with the inputs that are needed for automated systems, truly automated systems to be able to operate in airspace. I know that that's something that Mike and Jay Merkel are going to be talking about here in a minute, but there's so much work and so much science that needs to be done, and so much cooperation with the Air Force and with NASA to be able to ensure that we're getting the inputs we need to develop these systems over time. Because as you know, you can't really predict the weather, but you have to be able to accommodate the weather in the operations or ground the vehicle in a safe way. And so as we're trying to incorporate things like that with the sharing of airspace, the UTC systems, the traffic management systems, UTM systems, that's probably the trickier thing. And because so much of that is technically driven, I'm not the best person to ask about those timelines.
Thank you, sir. We did have one other question. What do you see as some of the early use cases, particularly in the rural air mobility?
Oh, absolutely. One of the things that we see for rural safety is that so 20% of the nation's roadways are in rural areas. Yet nearly 50% of the fatalities happen in rural areas. And one of the many reasons that is because people fundamentally are further away from first responders to initially get to them, and also from the hospitals that can provide advanced medical care. So one of the things that I would be most interested in is a safety application, and it's the way these vehicles can be used in the short term to be able to bring medical supplies to people, like we're testing out in Reno, Nevada right now with defibrillators, but also someday to be able to go to the sites, these remote locations on demand, and be able to bring people back to hospitals so that they can get the emergency care they need within the golden hour. So I think the safety cases on both ends of it are the things that are some of the most exciting applications that I hope are developed on a priority basis.
Super. Well, I know you have to move on. We really appreciate the time and the fantastic words. Again, express our appreciation to the team there in DOT. Looking forward to working together with that team as we move forward, and appreciate the time.
Absolutely. Thank you for being here. And I know that this is important from everyone, to the Secretary, to Dan Elwell, and the FAA Administrator. And I know Jay and Mike will do a great job of going into some of the technical details further. So thank you all very much for letting me come.
Excellent. All right. Brandon?
Yeah.
How's the poll looking?
It's looking, well, I don't know what people will find it surprising or not, but we're going to put up the results right now of the poll. 2025 has 46% of what year the first orb will take flight. 23% in 2030, and only 4% at I never will, which is pretty good, because I was a little worried that that might be a little too high. We're going to take a break for our polls for the next one. Of course, you can always ask questions in Slack and YouTube, and we will be bringing those live into the sessions, and we'll do one more poll before the end of this afternoon as well. Who do we have coming up next, Nate?
Next up, we have FAA. We have Jay Merkel, who is the Executive Director of the FAA's Unmanned Aircraft Systems Integration Office. Jay is responsible for facilitating FAA's safe integration of drones into the national airspace. And he coordinates that across all of the FAA's lines of business, the staff offices, to ensure those integration activities are aligned with the agency's overall mission. He's been critical, I know, extremely busy looking at a variety of different use cases actually right now during this COVID period. Might we be able to use some of our unmanned vehicles in ways that allow us to keep our social distance and to get the supplies to those medical supplies to those who need them right now? And I know we've been extremely busy with that, has done fantastic work with the IPP over the few years, and really leading this innovation in aviation, and looking forward to hearing how we can take some of the lessons learned from that into this advanced air mobility world that we're slowly moving into now. And so I'll hand it over to you, Jay. Thanks for joining us this afternoon.
Thank you, Nate, and thank you to all the organizers of the Agility Prime conference here. It's an honor to have an opportunity to speak with you. It's fabulous to be able to partner with DoD and with NASA. We've partnered with both in the past many times, and we look forward to that opportunity again in the advanced air mobility area. So my office does do the drone integration, but we also were recently chartered to do the urban air mobility or advanced air mobility integration as well. And as Bob Pierce referenced, that we will be leading the charge in bringing that to the XCOM and enabling the XCOM to look at that across the various agencies who are stakeholders. And I always like starting with reminding myself and others that it's the FAA's goal to fully integrate the UAM or AAM operations into the system. Davis gave you a very good long-term, short-term to long-term vision of where we're going with AAM. And we share that vision with NASA and are working with them to achieve that vision. Along that way, we have many opportunities, both in the near term and the midterm, to really bring these operations into today's NAS, National Airspace System, and into the NAS that's evolving. And that NAS has been evolving for about a little over 110 years. Manned aviation took approximately 100 years to get to the point of density and complexity it was before we saw the advent of UAS and really UAM. And so for the last 10 years, we've been trying to catch up on these either small vehicles or now these larger vehicles and bringing them into the system. And several people have either mentioned it or have experienced the frustration of dealing with the FAA in the past and have seen the growth we've gone through in particularly the last 5 years. And having been a part of that, there are two fundamental changes I think we made. And assuming my first slide is up, the first change we made was realizing that we had been relying on the patterns and the norms of manned aviation, the aviation system we had all grown up in. And we had to step back and rethink, how did we get to this point in manned aviation, and what does it mean in terms of unmanned aviation, either through small aircraft or larger. And the first thing we realized is in manned aviation, particularly since the last major innovation, which was radar separation procedures in the 1970s, the interfaces between the aircraft, the airmen, and the airspace have remained relatively stable. The information that exchanged, the roles and responsibilities, had all remained relatively stable. And that's just not true. It's not true with UAS, and it will not be true with UAM. And so once we realized that, it allowed us to make the fundamental policy and cultural change that we realized we could no longer rely on the somewhat sequential systems we had in the past, where everyone knew their role and did their role in sequence. But we had to relook at all of this, and that's where we started thinking of it as an ecosystem and started talking to ourselves about it. And that's why we love the way NASA has embraced UAM as the ecosystem, because we see it the same exact way. The other thing that made us do is make sure that we were looking for those changes in the system. And that was what might have been done by an airman in the past in simplified vehicle operations is done by the aircraft today. And likewise, what may have been done by an air navigation service provider will now be done by the aircraft as well. And we may have other roles and responsibilities and information exchanges that change over time. So we've been keenly focused on that for about the last 5 years in UAS, and we've used that to enter the UAM space. So we've taken all those lessons and moved into the UAM space with that same information. The other fundamental policy change that we made was we decided that we needed to stop trying to regulate first and then operate. We needed to reverse that model and learn to operate first and then regulate based on the information that we got. So we took that approach in UAS, and we're seeing tremendous benefits across multiple mission areas, multiple vehicles, where taking small steps in operation, gaining the information, allowing things to move forward, has allowed us to gain more and more complex operations to the point that we now see some relatively complex package delivery operations ongoing throughout, Christiansburg, North Carolina, and now under COVID, expanding quickly to the villages in Florida and other locations, medical campuses, et cetera. And that operations first philosophy and policy has really paid off, and we're pursuing that as well. But by doing that, we realized we had to exercise our current regulatory framework, which is quite prescriptive in many ways. But in order to get to the new performance-based rules that we knew we wanted to achieve, both with UAS and now with UAM, we knew we needed to collect that data. But we had to evolve from prescriptive to performance. So one of the messages that you consistently hear Mike and I say is, there's no need to wait to engage with us. We are ready to engage with you. We are engaged with a number of companies, primarily in aircraft certification, which is why it's Mike and myself here today. but also moving into flight operations and interface with our air navigation service provider, the ATO. UAM is really the capstone of our integration plan that we have, moving up from small UAS to more and more complex operations, up to AAM as the capstone. And we've been working at the pace of the innovators and of the innovations that are coming out. One of our lessons learned in this space and in the smaller UAS space is it does no benefit for us to lag the innovators or for the innovators to lag us. We have to move in unison together to achieve the safety goals and to get the economically viable and scalable operations we're all looking for. That being said, we've talked about a lot of analogies with what we've learned with the drone industry. We want to be very clear that we do not see UAM as scaled up drones. UAM are aircraft and infrastructure that will support safety commensurate with the type of operations where we see passenger carriage for hire or large cargo carriage for hire. So you will see us approach this with much more of the safety rigor associated with transport aircraft than we will with the light sport aircraft kind of approach. But that being said, we understand we need to do that in an innovative way. So I'm just about to turn this over to Mike for his piece, but the next part I'm going to shamelessly steal from NASA. We absolutely latched on to their approach of the 5 pillars. So we are completely aligned with NASA in the way they see the aircraft, the airspace, the airmen, the infrastructure, and the community as vital to making all of this work. I think one of the challenges for us in the FAA is we do not regulate the community. We engage with the community, we don't regulate. So we need a number of other partners outside of our safety mission. I think this is an area where we can all benefit from getting more and more partners. And I see we've got several of the voices in that area coming to the Agility Prime. But this community involvement, it's absolutely essential. We've seen it with manned aviation, that if the community is not involved, they will not accept operations in or around an airport. We've also seen it with the drone community, where we've done a good job of engaging the community, explaining the operation, addressing their concerns, being very transparent about what we're doing. Both as the operator and as regulator, we've been successful. And unfortunately, I've seen a few very recent great ideas in people doing COVID relief that just failed utterly because they did not engage the community, and the community fought back immediately. So I think that's one of our opportunities and challenges we see. We know how to do the aircraft piece, we know how to do the airman piece, we know how to do the airspace piece, but it's engaging with those who do the infrastructure and those who do the community, ensuring we all move that together. Now, I mentioned a few minutes ago that we do engage as the total ecosystem, and we keep our aircraft cert partners aligned and coordinated with our flight standards folks, along with our air traffic folks. But primarily, most of these aircraft are in certification preparing for operations. So that's why there's a tremendous emphasis on aircraft certification for these aircraft. And that's why at this point, I'm going to turn it over to my colleague, Dr. Michael Romanowski.
Excellent. Thanks a lot,
Jay. I really.
Oops, sorry.
Sorry.
Go ahead.
I'll really interrupt and do a quick introduction for Dr. Mike Romanowski. Sorry about that. From the FAA Aircraft Certification Services, he's the Director for Policy and Innovation Division. Prior to joining that division, he was the FAA's Director of Commercial Space Integration, where he provided executive leadership and direction for the evaluation and regulation of commercial spaceports, launches, reentries, and integration of those operations within the national airspace system. He also served as the FAA representative of the White House National Science and Technology Council as his Committee on Technology. So certainly not unfamiliar with bringing new things into the airspace. Certainly he's done fantastic work on breaking down barriers. I have to say, as we go and talk to the different manufacturers out there, it's a great thing to hear. You know, the FAA is not slowing them down. It's interesting. You read articles and they say, well, regulation in America is going to keep this from happening. You're going to have this technology go elsewhere. But I'll tell you that the gentlemen that are here and the teams that are supporting them are getting rave reviews from at least all the manufacturers I've been speaking with, and I think they have a bright future for a very sensible, safe approach to moving this industry forward. I'll let Dr. Romanowski take it from here and spell out those details.
Thank you so much, Nate. I mean, I can't tell you how much I appreciate that introduction. It's just phenomenal. Really, it warms the heart. I also want to thank Jay, and I'm going to be building a lot on what Jay had to say here in terms of, because he talked about the big picture, but I'm going to bring that into how we're certifying the vehicles. But I do want to add that we are looking at the certification of these vehicles in the concert of their operations and their integration, so that we're looking to make sure that we do, as Jay pointed out, line up the certification into the operation and its into the airspace. I also want to give a strong shout out to Davis Hackenberg and Bob Pierce. NASA and the FAA have been really strong partners on a number of fronts, but I think no stronger than in this area of urban air mobility, advanced air mobility. We continue to work very closely with them. And Nate, we're really looking forward to further strengthening the partnership that the FAA has with the Air Force as we take on the new aspects of Agility Prime. I got to tell you, these are extremely exciting times. And I think that's reflected by the fact that we have 1,000 people linked into this webcast right now. Personally, I believe we're heading into a new golden age of aviation where we're seeing innovation really come to the fore. And with that innovation, we talk a lot about risks of technology and the like, but I want to personally, I think over the history of aviation, we've shown that technology is in fact an enhancer of safety. And I think we're going to find as we move through these and really safely certify these vehicles, integrate their operations because of a lot of the features of these types of vehicles and what they bring to the table. I think we're actually going to see safety enhanced as we move forward. And again, that's going to be on us as regulators to ensure that the safety objectives are met, but it's also going to be on the industry, the manufacturers and the operators to make sure that they're doing the right things and behaving in a safe manner. At the FAA right now, certainly in the aircraft certification world, advanced air mobility has become big business. It's a major driver of what we're doing right now. And when I say that, I would say that we're currently working with, the number varies, but somewhere around 30 unique projects with companies right now geared towards certifying advanced air mobility vehicles for certification. These come at various levels of maturity. We see that there are some that are more initial exploratory discussions to some that we're in hardcore discussions on certification requirements, means of compliance to certification requirements, and really looking to work with those companies as they try to make those programs a reality. One of the things that does surprise people, and when Jay was talking about the regulations and their ability to use the regulations, it may surprise folks that the FAA regulatory framework really is up to the task of safely certifying advanced air mobility eVTOL vehicles. First, we actually have some not widely recognized, but some significant flexibilities in how we apply the regulations and certification. We have with a tool called special conditions, which allows us to levy requirements for technologies that are novel and unique that weren't contemplated in the regulations. We also have the ability to define special class aircraft when the requirements of any of the existing aircraft categories don't apply. But maybe even most importantly, as it comes to the advanced air mobility, is back in 2017, new rules became effective for small airplanes. That's our small airplanes are governed under what we call Part 23, and that sets out those requirements. And one of the things Jay talked about was moving away from a prescriptive nature of regulation. Well, that's what Part 23 did. Part 23, we rewrote the regulations to, in effect, eliminate the prescription and replace all the prescription in the regulations with clear safety performance requirements. And as a result, our regulations for those aircraft really became technology agnostic and ended up stimulating a whole host of innovation. The other part of that that's really powerful is it gives us the ability, by design, to accept compliance through FAA accepted voluntary consensus standards. So that's incredibly powerful when you really talk about promoting safe innovation and the like, because as authorities, it gives us access to the full pool of the world's experts across the full scope of the technologies that are being applied to the aircraft. And I got to tell you, this is an area where the industry has been extremely active in supporting the development of new consensus standards. All the technologies for advanced air mobility, from the systems to the electric motors and propulsion. There's a whole host of things that the industry has taken on and FAA is engaged in terms of development of those consensus standards. So we can't, and frankly, I think the other area where I want to give a shout out to NASA here is, NASA's done a lot of work with their R&D to share the results of that R&D, where that community looking to develop consensus standards can leverage the data that's coming out of those initiatives, out of the research programs, so they can look at the data and further the development of those consensus standards early on. And that's something we really want to see continue. We have it as a strategy in the FAA. We know NASA does, and working with the Air Force, we hope to further that as well. So what we can do here is we look at the consensus standards that are developed and evaluate whether or not those will achieve the safety objectives. And if they do, we accept them as a way to comply with our regulations. Now, it's important to note we're not bound, or the companies aren't bound to only use those consensus standards. We can work with them to for other means to show compliance. We have a whole host of guidance out there that are called advisory circulars that give us the ability to accept, show ways to comply with our regulations, and those are still out there and available. We could also work with companies on specific processes that they can show they develop to show they can meet the safety requirements. So what, as we say, is we have a framework that really allows a straightforward certification path, because most of these eVTOL aircraft can in fact operate as an airplane, and in fact are covered by that Part 23 regulation. Those that aren't, we can still leverage huge portions of that regulation. We have our Part 27 helicopter requirements. We have our engine propeller requirements. We have a whole host of regulations that we can merge together as the specific vehicle concept and configuration comes into play to set a really robust safety objective for those aircraft. As I mentioned before, we're really looking forward to working with the Air Force here in a number of ways. We are excited that the companies that are going through certification can work with the Air Force and leverage some of the unique capabilities and facilities that the military has to accelerate progress in the field. And again, I think we've seen some of that with some of the partnership we've had with NASA, and I'm going to highlight one of those later in the discussion. But one of the things we're working with Nate on right now is how do we in fact bring the Air Force folks with the companies into the programs, and respect the agreements that the companies have with the FAA, as well as respective agreements they have with the Air Force. We have a really good framework to leverage when we do that. And that's called our military certification office. And I think earlier today, Frank Delsing from Air Force Research Labs probably commented on the military certification office. And I know Derek Morgan, who manages our military certification office, is out there in the audience listening in. We see that is providing a core access point in where we can then work with the certification teams that are doing the unique work with each individual project. And we plan on working with Nate and the rest of the Air Force team to work through the details of this in the coming weeks to make sure that we've got the right arrangements in place for that partnership. But again, it's I can't tell you how excited we are to be moving with everybody on this one. Again, what I do want to come back to again is some of the value that some of the government partnership can have here as we move forward together. And I want to highlight that with an illustration of a cooperative arrangement we have with NASA right now. That, should this crisis end, we're hoping to apply, do some testing with NASA's facilities this summer through a cooperative agreement we have with them, where we would look at the cockpit motion simulator facility at Langley and the vertical motion simulator at Ames. The idea would be we intend to put our FAA engineers and pilots into those simulators, working with some of the simplified vehicle operation, flight control systems, crew interfaces, so that we can look at validate our approach to certifying those cockpits, but also give our flight standards inspectors and pilots the insights to solidify training requirements and pilot requirements for those types of vehicles. So it's an exciting type of thing that really shows about the power of that partnership, where and we'll have some of the companies involved in that as well. So if we can find ways through Agility Prime to leverage that kind of partnership, that kind of activity going forward with the pull of the U.S. military in terms of being a customer, I think we're set up for some great things. So with that, Nate, I'll come back to you and we can get into the Q&A.
Fantastic. Thanks again. Just very encouraging, I think, to everyone to see how the work has already been happening, and again, to talk to the OEMs with that partnership that's there. One thing that certainly resonated as we were looking at across the chat as this was going on is this concept, and you'll actually see it on the fantastic artwork that's being developed real time here. This idea of operate first, then regulate. Can you tell us a little bit, what does that look like, and what are the new opportunities? How can we do that? How can we look maybe at what was done in the IPP and bring that forward? And does it use a similar construct? How do you see that coming together? And what are some of the new opportunities to really make that go forward effectively?
Well, I'll start and then I'll let Mike jump in. So I think Mike actually laid out the details for you in part 23 and in other areas where we can use the existing framework we have today to qualify your aircraft in airworthiness and get those initial operations up and running. And I think we have a number of flexibilities in the regulatory framework to do that. It's really the message Mike and I have is don't wait to engage us. Don't assume we don't have the we are limited or don't have flexibilities. We will find the flexibilities to get you up and running as long as it's a safe operation. And I'll turn that over to you, Mike.
Okay, I think again, what we saw with UAS, and we're heavily involved in the UAS activities as well, is those initial operations gave us, and we were doing those over the more benign environments in lower risk areas. where we could take what's effectively an experimental operation, validate our assumptions of how we thought this would work, validate the capabilities that a vehicle shows and the methods by which they're being operated, so that we can gain the confidence to safely expand those operational capabilities. So it's really building on success, but also building on the lessons learned in a much more agile way than trying to perfect a future scenario and then perfect requirements to that scenario, and then find out when we start operating that scenario really wasn't what was the actual intent as well. So again, I think with projects like this, we have a lot of companies in test right now. We're working with those companies to understand the results of those testings as they gear towards their nail down their configurations and move towards their certification testing. Opportunities like Agility Prime to partner, or the I apologize, Davis, I still think of it as the Grand Challenge, but the Advanced Air Mobility Initiatives at NASA, when companies can go and operate in those environments, and in the research realm, we can take and leverage that information to solidify the approach that we're taking on the certification. I think it really, and the operational aspects we can really build.
Thank you. One additional question. Can you shed some light on which public use cases might be the first to show real potential, and what is the flexibility for certification for these public use cases?
Jay, do you want to comment on the use cases? I know there's certainly, the market's going to determine which are the.
Yeah.
Go ahead.
The primary use cases in public safety that we see are really replacing helicopter operations with urban air mobility. So it would be helicopters for medical emergencies, helicopters dispatching for search and rescue. We have even seen use cases where to actually get around ideas like you need a visual observer, training the person who's being dispatched as the emergency responder as a visual observer, which is the same exact technique that Chula Vista does. Each and every one of their police officers are visual observers and tell the pilot if the airspace is clear before they dispatch the drone as a first responder. So sort of leveraging on that. But those are the main use cases we hear people talking about and gravitating towards. I think there are a number of military applications of those same sort of use cases in terms of medevac and that sort of thing. So Mike, anything else you want to elaborate on?
I think I just want to add again, where one of the things that impresses me about a lot of the vehicles we see right now is they have levels of redundancy that are much more aligned with what we see in fixed wing aircraft than what we may see in conventional rotorcraft. Their capability for multiple power system losses and reallocation, redundancies in flight controls and in structure that aren't there. So again, I think it's the kind of thing where obviously we have to do our work correctly. The companies have to do their work correctly to validate those capabilities. But it is astounding when you start looking at the step change that you could see in some of the, the infrastructure of the vehicle itself.
Wonderful. We did also want to know, given we have a global audience, what are some of the lessons learned from the EASA and other international organizations about the development of regulations and the establishment of this ecosystem?
Oh, Mike, that's prime for you.
Yeah,
you can deal with
that one's for me. Yeah. So we work closely with EASA, as we do with a number of authorities around the world. One of the things that's very important for companies is, they work in an international marketplace. They need to be able to export products around the world and establish that. So I think, again, what we see with EASA is they've taken a slightly different approach in terms of how they're forming regulations. We see our approaches as somewhat compatible as well. When we start looking at certifying vehicles, again, we think we have an approach with our small airplane requirements and our ability to issue special classes where those requirements don't fit, that are custom aligned to the unique nature of those vehicles. That, again, Jay mentioned operations first, that gives us the ability to learn, do we need to adjust the certification requirements as we move forward? Do we need to set a change in the standards as we go through this processes and evolve into maybe a more unified eVTOL regulatory approach for reasons of their own, and in part, I think, because of their constraints on operating requirements. EASA took a slightly different approach, but again, I think they are consistent in that they're embedding a lot of their operating requirements into the certification of the vehicle, where we work with our operational requirements and add those in after or concurrently as well. So different approach, but I think the results for the company.
So as a follow-up to that, can you talk a little bit the vision internal to FAA on what autonomous operations might look like? And as you can imagine, in the DoD, as we look forward to this, the ability to have the vehicles similarly to the commercial environment, what do you see in terms of starting to go down a path of certification, and where might there be opportunities for collaboration across the agencies?
Well, I think there are a lot of opportunities for collaboration, huge opportunities for collaboration. And I think, Nate, what's inherent in there is understanding what do we mean by autonomous. I mean, some of what the automation we have in systems today, many years ago, would have been called autonomous, right? But it's really that level of how much supervision, how much oversight is really there. You know, when you get to the end-to-end, all decision-making, full machine learning, and that's an end state, but there's a lot of stages along the way that we're going to work through, right? Early levels of autonomy. I mean, when we see current vehicle concepts, there's a lot. The role of the pilot is shifting, the crew is shifting, right? It's simpler to operate the vehicle. You're not the vehicle is being programmed to take certain actions when certain conditions apply, in terms of triggering someone to go and land the vehicle, for example, versus getting to a point of complexity in the operation and say, okay, pilot, you have it all, right? There's a different philosophy inherent in some of the simplified vehicle operations. Those are some of the things we're going to work through as we look through how do we qualify the systems, how do we qualify the operation and the crews. Going out into a more programmed mode where folks are more or less supervising the automation. Not much different than what we see in a lot of aircraft now, right? It's just the different tool sets and skills that they may have at this type of vehicle versus a full of transport airplane. Then at the end, as we're going to continue to, a lot of folks are talking about operating learning systems in shadow modes and developing and showing that the vehicle would in fact conduct the proper mitigation and response to situations. Most of it's all on the emergency response side. Those are things that, again, working through together, I think, in running scenarios and looking at the capability and looking at ways to validate various machine learning and autonomy. I think those are things they're further out, but those are things we can certainly work together.
Super. Well, gentlemen, thanks so much for your time. Again, it's amazing to think about entirely new types of aircraft and the hard work that it takes to bring something like that, just to actually make it fly, but then to go get it to fly in a way that meets the levels of safety, that preserves that gold standard that the FAA maintains around the world for certification. It's the hard work of your teams that are making that happen. There's some really groundbreaking things that have happened with some of our small drone programs, and hopefully we can continue to leverage those. But look forward to working with you in the future. Thanks for spending the time with us today, and be in touch soon.
Hey,
Thanks very much, Nate.
Bye.
Bye-bye.
All right, Brandon.
Thanks, everyone. We've been going for 97 minutes. Pretty good. Thanks, audience, for sticking in there with us. We can see the numbers are still up. It's fascinating content, and we've got a whole lot more to go. So in the honor of it's 5 o'clock somewhere, and bio break, beverage break, you name it, we're going to take a break until 45 after. I think that's about 7.5 minutes. So we're going to roll some footage, some entertaining stuff in the background while our team recharges, get the next speakers ready to go. I can promise you it's worth coming back at some of the coolest stuff we have for the whole week coming up, and one of our best speakers. So please come back at 45 after.
And he really means 45 after, and you got to be back right at that time, because if you are not, you're going to miss Gwen Leiter, who I think is probably one of the leaders of innovation in this space. You don't want to miss it. You have short time. On your mark, get set, go. I'll see you back here at 45.
Nice to be in orbit.
Welcome back, and I hope that everyone had the opportunity to charge their glass with beverage of choice. And I sure hope that everyone is ready for the few speakers that we have remaining for this afternoon. We're going to start off the second half here with Glenn Leiter, who I personally believe has done one of the most exciting and innovative things to spark ingenuity literally across the globe. Gwen is the CEO and founder of GoFly. She leads a team of over 3,800 innovators, 103 countries, to create a multitude of personal flying devices. What could be more exciting than that? I understand I'm a little biased wearing this green bag that I'm in. It was supported by Boeing and Pratt & Whitney with over 20 other aerospace partners. This GoFly concept, this GoFly prize, is catalyzing the creation of jetpacks, very exciting, flying motorcycles, probably as exciting, maybe more, and personal flyers to make the dream of human flight a reality for so many. Glenn, absolutely love what you're doing. I'm thrilled to have seen just the communities that have been created by this project literally around the world. Congratulations on the fantastic work you've done so far. And thanks so much for joining us this afternoon. Love to hear more about it and what we can learn from your fantastic experiences.
Well, thank you, Nate. And first, let me start out by saying thank you to not only Colonel Nate Diller, but the entire Agility Prime team, including Brandon and Tessa and everyone that you've heard from thus far. It takes a community to build this. And given the global nature of the events today, you have managed to make a seamless programming. So well done. Kudos to you. And thank you so much for inviting me to join all of you. I hope everyone listening is safe and well. Greetings to everybody from the New York tri-state area. To anyone who's listening on the Air Force and the Navy, a big thank you today. From all of us in the area. We had the Thunderbirds and the Blue Angels from a flyover, which certainly was the highlight for us, not only today, but in quite some time. And that was, of course, a give back and acknowledgement to first responders and medical professionals on the front line. So a thank you to the Thunderbirds, the Blue Angels, and to all of you for giving us community in a time when we're all social distancing. What you've heard today and yesterday is truly that we are in this new golden moment of aviation. We are on the cusp of a revolution in aviation. We are on the cusp of a revolution in mobility, in the way we move around the globe. And that takes not only one company, but it actually takes a community, because there are 4 different areas that, in order to get us where we all want to be, will be impacted. And the first is, obviously, we need the technology innovators, but we also need the regulators. And so too, we need the funders, we need the investors. And then the fourth area that we really need is the general public. We need social acceptance. And so everything that we design needs to be designed through a prism of both safety and noise mitigation and what is best for the general public. And so that is GoFly's lens of how we do everything that we do. I also want to say thank you to fellow panelists. We have been working together for years and years. Bob Pierce, who leads the aeronautics at NASA, you heard from, with Davis Hackenberg. Their colleagues PK and Eugene too have been instrumental in helping GoFly and our GoFly teams. So too at the FAA, Mike Romanowski and Jay Merkel, along with their colleagues Earl Lawrence and Rick Domingo, have been the most phenomenal partners for our GoFly teams. What I can unequivocally say is that any technologist who is looking to build new flyers could not have a better partner than the FAA. They are ready, they are willing to ensure that flights, that pathways to flight are available, and that public safety is maintained. They are, frankly, a new FAA. They are the best partners one can imagine. So too, Today, you'll be hearing from Peter Shannon, investor Radius, who was at our fly-off and who's been a strong supporter of GoFly. As too, you'll hear from Mark Moore as well, who attended our fly-off and frankly was one of the earliest supporters of GoFly. So what I think you will experience is that the people who are involved in the early aspects of this community have been working together for many years, and it is so very exciting for all of us to welcome new players into this community. So thank you, thank you. As most of you probably know, GoFly had a big event right before the world shut down in February, and as a picture is worth 1,000 words, I think let's start by going to a 2-minute video. You are all now the first to see this. We've had this video done for a while, but given everything going on, we have not publicized this. So for 2 minutes, if you can run the video, and then we'll talk a little bit more about GoFly and programming that we are still doing for the benefit of the general public.
GoFly's had a profound impact on the next generation of aerospace innovators around the world. The excitement amongst the new generation has really been fantastic.
This is a great experience to get in front of all these people and sort of showcase our ingenuity and our technology and push the boundaries of what's possible.
It's so cool to be, elbow to elbow, shoulder to shoulder with the other teams working on this stuff. The brilliance of GoFly really is bringing everybody together for a common goal.
It's a competition. There is some rivalry, but what's even stronger is a camaraderie here. Every team I've spoken to, everyone is like, how did you do this? How did you do that? Because let's face it, this isn't easy.
We know what we're capable of, and now we are able to show this to all these people, and we don't only get to share what we've done, but we also get to share our vision and how we envision the future of personal flight.
The GoFly Prize is designed to catalyze the creation of these personal flyers, to push what is possible, and frankly, to make the impossible possible.
Our industry lives and dies by innovation, and that means we need innovators, which means we need to keep the next generation involved and excited about aerospace.
Without innovation, we're not going anywhere, we're stuck. And we only got here because we weren't scared to follow our dreams and dig into our imaginations and use that to drive us.
We are all feeling so thrilled that Team Tetra won the Disruptor Prize.
That's my team, that's our team, we won! Yeah!
We are so energized for what comes next. Our teams have been working for 2.5 years to try to capture that grand prize. Unfortunately, that did not happen today, but we together have decided that prize is still up for grabs.
We knew this risk going in. They set the bar very high. In cooperation with GoFly, we're going to carry the prize money forward, let the innovators continue to mature their designs, and hold that standard high.
For anyone around the globe who thinks that they can make people fly, join us. We'd love to see what you can do.
So I hope you enjoyed that video. We had a phenomenal time with all of our teams presenting their innovation to the world at NASA Ames a few short weeks ago. So what we did at GoFly was we put on this global competition that is still ongoing, right? You can still enter the competition. What we said to the world is we would like to have catalyzed the creation of a safe, quiet, ultra-compact personal flyer that can travel for 20 miles without refueling or recharging. It can be manned, it could be unmanned and carry a 200-pound dummy, but these are the flyers of the future. And frankly, what you have heard thus far in other talks through Agility Prime is that these types of devices are exactly what the world is looking for from both a personal mobility standpoint, but also from personnel movement, first responder, rescue situations. And so our GoFly teams around the globe are creating these devices for a future of mobility and for a future of first responders and many different types of use cases as well. We have over 3,800 innovators from 850 teams and 103 countries participating in GoFly. So what we've done is we have set up a system where we are providing incredible help to our teams as they are frankly changing the world. We have master lectures where we have frankly the deities of aerospace talking about propulsion, noise mitigation, VTOL, and different aspects of all different parts of flight. We have made over 50 of those lectures available to the public. So any of you who are listening, if you would like to learn more, please feel free to go to our website, goflyprize.com, or you can go to our secondary website, herox.com/gofly. You will be able to find those lectures, and those are from the masters of engineering and development. They truly speak to being at the top of their games in all aspects of safety and technology. So I'd encourage all of you to be able to look at that. So too, for our teams, we have mentors. We had over 250 mentor pairings. Our teams ask us to be paired with specific mentors because, as you've heard from a number of other panelists, there are so many different types of intelligence that is needed to build these vehicles from so many different disciplines that it is important to be able to access that help should you not have everybody on your team. So GoFly has put in a whole system of mentoring for all of our teams. Some teams have worked with 10 mentors. Some teams have worked with 0 mentors. It is entirely up to them. Once they request a mentor, we find one that works with them. We have been the recipient of tremendous support from Boeing, from Pratt & Whitney, from 20 different organizations, including Vertical Flight Society, AIAA, SAE, GAMA, EAA, AOPA, AUVSI. And what GoFly has done, and frankly, one of the things we're most excited about, is that we have created this community of organizations, of builders, of funders and investors, of PR teams that are actually helping to build an ecosystem, to help build a community with the regulators where we can take all of this technology to the next level and bring it to the public so that collectively the public can decide the best way forward. We have in-kind sponsors for our teams, including insurance. We've been working with Global Aerospace, one of the largest insurance companies in aviation, to provide a pool of insurance to our GoFly teams because many of the companies, and certainly the smaller companies in the world, have trouble getting insurance. So we have ballistic recovery system experts and discounts, battery discounts for the teams. And as I spoke before, also, we've been really in lockstep with the FAA in terms of the pathways to flight process. Every week, GoFly has our weekly call with the FAA, where over 50 members of the FAA are on that call in the FISDOs and the MITOs, helping our teams get to both fly and to be certified. And so what I can unequivocally say that the FAA is 100% behind this new age of aviation and making sure that it's done safely. So where are we now? The grand prize, as you all heard, is still outstanding. There's $1 million that is prize money that is still outstanding for teams. Anyone who's listening, you can join an existing team. You can create a new team. An important thing to know is teams keep their own intellectual property, so it's all yours. We are helping to create this community, to create the ecosystem, and to catalyze the creation of these personal flyers. So we will be announcing our next schedule shortly. We're waiting for the pandemic to be able to allow many of our teams to regroup together. But we still have this $1 million prize outstanding. We encourage you, if you are interested, to contact us. Go to goflyprize.com. Contact us directly, info@goflyprize.com. Email us, info@goflyprize.com. And even if you are not interested in participating in GoFly, we would encourage you to take advantage of the wealth of expertise that is available to the public through our master lectures. anyone who is in this world can benefit from at least one of our lectures. Several of our masters have told us that they've watched the master lectures and have learned from the other masters in the other disciplines. So I think there's a tremendous amount of information available for all of you as we create this community together. I would say as parting, join us to be a part of this phenomenal community. We are so pleased that the Air Force, that Agility Prime is working to better our community and to create an even larger community. And to all of our teams that I know are listening right now, we are 100% behind you. Be safe and well for everyone. And do not hesitate, everyone, to contact us if you need us. info@goflyprize.com. Wishing you all the best. And here's to a very bright future. Take care.
Gwen, thanks so much. Really appreciate the fantastic work that your team has done, and we anxiously await to see who the recipient of that prize is. I'm sure there will be many out there working very hard. So thanks so much for your time.
Thank you, Nate.
Thank you. All right. Before I turn to our next guest for this afternoon, there's one quote that came out of this publication that Peter's going to talk to on, and I just want to repeat it for the audience here. The mastery of advanced aerial mobility, given its wide-ranging impacts on society and the economy, will be one of the highlights of civilization. Those are strong words there, Peter. That's fantastic language. So, ladies and gentlemen, we have Peter Shannon. He's an investor that's focused on advanced aerial mobility and its application towards a positive impact for transportation across our entire economy. Peter's active in the aviation community around regulatory and technology issues critical to enabling high-scale adoption of aerial mobility systems. Peter helped create a national vision and roadmap for urban air mobility as a member of the Committee on the Urban Air Mobility Research and Technology through the Aeronautics and Space and Engineering Board of the National Academies of Science and Engineering and Medicine. Peter is also an appointee to NASA's Aeronautic Research and Technology Roundtable. Peter, thanks for the time that you put into developing this document. Thanks for joining us here, and looking forward to your discussion, some of the lessons learned and things that this community should take from that fantastic effort that you and your counterparts put into developing this document under the National Academies.
Absolutely, Nate. And thank you very much for having me. I've really been looking forward to this session and taking some time to share a little bit about this report. So today I'm going to be describing this report, of which I was a co-author. It was commissioned by NASA's Aeronautics Research Mission Directorate in early 2019. My committee and I worked on this report throughout the last year, published it just recently in February. So I hope that this quick 20-minute overview will serve as an introduction to the report's contents, findings, and recommendations. And certainly anyone with further interest can download the report for free from the National Academy's press website via a link here on slide 2. And let's advance to slide 2, please. So in this report, we'll cover the committee and our activities, the statement of work that we were given by NASA. We'll outline the vision, the national vision for advanced aerial mobility that we created, as well as talk about the path forward, execution towards achieving that vision. And I'll end with a brief summary of the recommendations that the committee came up with in closing. Next slide, please, slide 3. So the committee's statement of task was to lay out a national vision for advanced aerial mobility, as well as research recommendations to overcome the technical, the regulatory, and also the policy barriers that sit between today and achieving this vision. From the beginning, we recognized that the dynamism in this space across vehicle development, new mission profiles, emerging applications, as well as infrastructure and airspace system management made this a challengingly broad topic to cover comprehensively, all the more so given our committee's limited time and resources. Further, prior National Academies committees have already published deep investigations into topics within this space, such as autonomous flight and highly automated safety management systems. So we instead sought to create a set of findings and recommendations that would stand on the shoulders of this prior work that would bridge across disciplines and serve as a basis for further work by others. We strove to lay out a long-term vision for advanced aerial mobility that touched on the comprehensive set of stakeholders and key requirements for its success, as well as to closely explore the ways that the public and private sectors must coordinate in order to execute on this vision. This vision is ambitious in its ultimate embodiment, but actionable with incremental steps toward it today and concepts for public-private partnering that can serve us well into a future where high technology increasingly intersects with our physical infrastructure. In this, we hope to have delivered a framework that remains relevant years into advanced aerial mobility's deployment and maturation. Let's go to slide 4, please. Our committee is listed here with Nick Lapos of Sikorsky serving as our chair. We met throughout 2019 to hear from experts from industry, from academia, from the startup community, and also the public sector. The report went through peer review in the fourth quarter of last year, the final round of edits throughout the holidays, and then just published it in February. Next slide, please. So to level set on scope, the committee looked at advanced aerial mobility to include a broad set of flight operations enabled by new technologies' impact on flight. In particular, electric propulsion and control systems, increasing automation, computing advances to include artificial intelligence, and the role of advanced aerial mobility to include manned and unmanned, autonomous and pilot supervised aircraft of any size and mission, operating in an integrated national airspace system across regions spanning from the very remote to dense urban areas. In terms of deployment, the committee heard deployment forecasts for vehicles with various capabilities and flying different types of missions. Overall, we see emergence of advanced aerial mobility happening first within two broad categories. Unmanned vehicles carrying cargo on low-risk missions, for example, over sparsely populated areas, over water, or in an industrial setting, and human-piloted electric aircraft, whether eVTOL, eSTOL, or conventional, flying like any other tail number in today's airspace system. With operating experience and manufacturing scale gained exploiting these capabilities across various markets, the committee sees further deployment of more complex operations and at higher scale in the future, tackling the more demanding but very promising applications involving high density and autonomy. Let's go to slide 6, please. So one question to consider is, why do we need a national vision for advanced aerial mobility? The committee saw developing a national vision and a plan to execute and achieve it as squarely in the national interest. Advanced aerial mobility leads to adoption of flight into many new applications for which flight was not previously suitable. The capability to apply flight for broad movements of people and goods is a profound step forward. The new applications will touch industries across the economy, some of which are being studied and planned for today, many of which will be unforeseen and discovered in the future by creative entrepreneurs. The United States stands to benefit both by adopting this technology as well as by taking industrial leadership of its creation. We are seeing more and more the strategic geopolitical leverage that control of strategic infrastructure technology delivers. In addition to being in our interest, execution on this vision requires close coordination between the public and private sectors, correspondingly requiring a clearly articulated vision that is shared by all. Let's go to slide 7, please. So as we gathered information and grappled with the scope of the question before us, we began to lay out assumptions and guiding principles based on what we were hearing from the community. Among these, regulation plays a necessary role for safety throughout the national airspace system. Safety is the highest priority consideration driving the design and planning of advanced aerial mobility systems, and it manifests in technical, in regulatory, and in societal acceptance issues throughout this space. Societal acceptance is a nearly equal factor that will make or break the rollout of many advanced aerial mobility systems. This extends beyond safety factors and gets to the public's opinion of the perceived benefits it delivers versus the impacts it has on bystanders, the environment, overall quality of life, and social aspects. Let's go to slide 8, please. The committee articulates its vision for advanced aerial mobility around the systems engineering challenge that it represents for the national airspace system. The vision is long-term and ambitious, and the committee believes it will be realized via a phased and incremental approach. Fully realizing the vision may take many years. However, there are high-impact victories to be had at milestones along the way that will create valuable new markets, grow industries, and positively impact society. Progress will build upon the standards, the technologies, and experience gained from each preceding step. We see that this progress will depend upon coordination among all stakeholders, both public and private, such that they build constructively upon each other, and such that the private sector is given clarity needed from regulators, as well as through standards organizations, in order to deploy resources and capital toward these goals. Let's go to the next slide, please. The gaps and barriers we outline in the report address the differences between the National Airspace System today and what the community envisions it potentially evolving to in the long term. There are many challenges that will have to be overcome to achieve the full potential that advanced aerial mobility technology offers. At the highest level, these stem from the fact that the airspace system in its present form was not designed to accommodate the density levels and automated operations needed to make advanced aerial mobility viable. To illustrate, we can find examples of these challenges looking across categorical gaps that exist between today's national airspace system and the one we envision for the future. So let's take a look at safety. Safety in today's national airspace system is very high for commercial air travel. Safety management in the NAS builds margin around known vulnerabilities based on years of collected data. Advanced aerial mobility introduces several underlying changes that correspondingly require new methods to be brought to bear in the approach to safety. Further, electric propulsion and automation may reduce instances of certain causal factors, but increase instances of other factors, or introduce new causes altogether. Moving to security, security is already a high priority in today's NAS, but the approach and technologies employed will need to change as advanced aerial mobility systems are scaled. Of particular interest are threats to digital communications links, establishing trusted communications as voice is displaced by data links, and safely managing fallback navigation methods for autonomous systems in the event of GPS denial, etc. Looking at resilience, resilience is the measure of a system's ability to recover from disruptions while maintaining functionality. Many aspects of this are handled by human-driven processes in today's NAS. However, as scale and complexity increase, this capability will increasingly need to be handled by systems designed for the task as the workload exceeds thresholds and the ability for humans to intervene directly. Collection, analysis, and dissemination of system reliability data will play a very important supporting role here. And with respect to communications, the majority of current communications between aircraft and air traffic control use voice spoken over VHF radio frequencies. Newer communication methods are needed to support greater scale and also to support the needs of unmanned or autonomous aircraft. However, consensus on many of the aspects of implementing this has yet to be reached. And this just illustrates a few of the gaps that we studied. The report lays out similar considerations for the other areas listed here. Let's go to slide 10, please. Now, the barriers to executing on the vision are also related to issues around the coordination required in order to introduce innovation into the NAS in a way that preserves safety and addresses the needs of all of these stakeholders. One root issue is that advanced aerial mobility is a multidisciplinary challenge. We spent a lot of time looking at the systems engineering challenge that it represents, and at first exposure, the system level complexities can appear daunting in some respects. However, this can and is being broken down into manageable pieces, as we collectively have with every other complex problem that we've tackled in the past. Overcoming hurdles will require collaboration between stakeholders across different areas of specialty, both within and outside of traditional aviation. No single entity is going to solve all of our issues ahead, but government and the private sector will have to coordinate closely to enable and achieve progress. Aside from safety, one of the most important barriers to adoption is societal acceptance of this new technology. Executing against this requires acknowledging that the public's perception of the various contributing factors to acceptance is as important as the factors themselves. Further, debates over privacy have impacted progress in early applications, including drones. All of these need to be addressed upfront and in a uniform and coordinated way. Likewise, with respect to environmental impact, it is as important to understand the direct environmental impact characteristics of advanced air mobility vehicles as it is to understand the public's reaction to these technologies. Our report makes several recommendations for research and other actions to get out ahead of these issues while they can be proactively shaped prior to large-scale deployment. Let's go to slide 11, please. Overall, it's important to consider a phased, iterative approach to deployment, testing, and introduction of new capabilities to the airspace system. It's not reasonable for a system of this degree of multidisciplinary complexity, with as many stakeholders involved and with regulatory involvement at every step, to self-assemble out of a mass of uncoordinated innovation efforts. Rather, coordination leading to interoperability and standards is essential. The committee saw the need for the public sector to take an active posture with respect to delivering to the private sector the clarity on high-level architecture, ConOps, performance requirements, or standards in order for them to deploy capital and resources to deliver the innovation. Likewise, the public sector should assess the new mandate, capability, and authority it will need in order to adapt to the changing nature of its mission in this new chapter of aerospace. However, we must carefully balance between providing clarity to enable the private sector while not being overly prescriptive or narrow in focus, both things that would actually inhibit innovation or result in wasted effort. The committee heard evidence to believe that viable applications of the technology and airspace system capability can likely be exploited even at the increments that are introduced. These incremental capabilities are directly constructive towards the systems required for high-scale urban air mobility, and the sooner they are fielded, the sooner experience with them is gained and further capability can then be introduced. The approach should, however, be flexible to react to and accommodate entrepreneurial advances that bring capability faster than anticipated. In sum, a very carefully considered balance must be struck. Let's go to slide 12, please. So the committee's recommendations are a combination of mechanisms to facilitate progress and collaboration, forward-looking research in pre-competitive areas, and ways to facilitate execution in the near term, such as development of the resources and assets for testing and development. Among the recommendations we made, I'll highlight a few. The committee recommended formulating a United States Joint Advanced Air Mobility Master Plan, and that NASA and FAA should form a partnership to manage responsibility as well as accountability across the various stakeholders and participate in its development to provide the guidance to enable private sector innovation. The committee also recommended that NASA prioritize research that develops high-level architectures, requirements, and supporting technologies to enable integrating advanced aerial mobility into a future national airspace system, and to, in coordination with the FAA, extend unmanned aircraft system traffic management concepts to accommodate the emerging advanced air mobility traffic in all classes of airspace. A supporting piece of forward-looking research in this area is a recommendation to NASA to work alongside industry and standards organizations to research protocols, data formats, and data exchange standards that support advanced aerial mobility vehicles in a geospatial real-time system supporting safety-critical operations that occur across the national airspace system, with the intent that the tools developed will provide the necessary clarity to catalyze and enable commercialization of system components by industry. This research would address the long lead time items needed to support more complex, automated, and high-density operations anticipated later this decade in support of urban air mobility. The committee also made research recommendations in support of safety and societal acceptance, recommending NASA conduct research, development, and testing of autonomy for contingency management in the airspace system, and to collaborate with the community to form a framework to conduct scenario-based studies to assess societal impacts such as public annoyance, public health, privacy, and environmental impacts due to advanced air mobility vehicles and associated infrastructure. All of this with the intent that the studies will recommend a path to implementation that prioritizes maximum public benefits. Finally, a recommendation to note is to establish a continuous flight test capability that supports rapid development of air vehicles, of flight operation practices, of surveillance and communications networks, and also of other system-wide management systems. This United States flight test capability would go well beyond currently available commercial or military test range resources in terms of both capability and availability as a continuous flight test asset, able to support rapid development of both platforms as well as specific end operations and applications. The committee believes that this will directly help U.S. competitiveness and industrial leadership. More detail can be found certainly within the report itself, and I leave it to those interested to download the report and explore further. Let's go to slide 13, please. So, in sum, if we create the right framework to enable private sector innovation, we can move faster to break down the complexity of advanced aerial mobility systems and build U.S. competitiveness in the process. The experience gained in applying advanced aerial mobility at each capability milestone to the mission for which it delivers value will constructively feed into insights that inform development of the next level. Over the course of this study, it became clear that the advanced aerial mobility market is poised for massive and rapid evolution over the coming decade, and that many other countries are viewing the advanced aerial mobility opportunity space as a potentially transformative societal element and an emergent driving force of their economies. Mastery of advanced aerial mobility, given its wide-ranging impacts on society and the economy, is of national strategic significance. Governments are beginning to take various approaches to compete for leadership and prepare for its adoption. U.S. leadership in advanced aerial mobility is in no way assured, despite our strong legacy in aerospace. The new technologies enabling advanced aerial mobility are widespread across developed and developing countries, and that their fundamental nature lowers the barriers to entry, despite the complex systems engineering involved. With a national vision for advanced aerial mobility development being in the national interest, and with the inseparable role of regulation in the aerospace system, our committee recommends strong and knowledgeable government regulatory establishment with FAA, DoD, and NASA technologists who are prepared to lead with guidelines in support and enablement of private sector innovators. And to wrap up, I'll end with the idea that, to ensure continued U.S. leadership, the committee recommends a clear statement of national will, and likewise a clear master plan and national commitment to execute it. So I do encourage you, with further interest, to download the report and dig into it. It fleshes out on several of these ideas quite a lot, and thank you very much for your time.
Peter, fantastic. Thanks for the work that you all have done there. I think it's great to have a group that is very knowledgeable about the space, knowledgeable across a variety of different disciplines, that took up that work, had the conversations, did the interviews, and put together the research to create the product that you did. I know over the period that you were developing the document, our particular effort was just getting started. And so I guess I would be interested, in light of where we are right now with Agility Prime in particular, what words of advice would you give to us and to the partners that are working with us here on the Agility Prime effort to potentially fit into kind of the framework that you all outlined with this study?
Well, I think it very much dovetails with the ideas that we were forming as we were gathering information and working on this study. And that DoD, in fact, has quite a lot to bring to the table in terms of experience working with the product and managing goals. And that is something that we confront as we simultaneously try to modernize the airspace system and bring groundbreaking new capabilities into it, while also addressing the needs of all of the other stakeholders, addressing the overarching priorities of safety and social acceptance of the system. We have a number of competing objectives that need to be balanced, and we have a very complicated sort of multidimensional effort to engage the private sector and give them the requirements that they need in order to allow them to go and innovate and figure out the solutions and very creative solutions that we may not be thinking of right now ourselves.
Super. Well, again, appreciate that. Look forward to kind of spending some time and working with the other organizations that you've listed there, seeing what the next steps might be in order to really put the recommendations into a strategy for implementation in a variety of different forms and fashions. So thanks for joining us. Looking forward to seeing you later on in the week. And with that, we will switch over now to our next briefer and final briefer for this afternoon. We've seen Mark yesterday with his teaser brief, telling us just a little bit about the work that Uber has been doing, the vision that Mark has communicated, and the one that Uber has been so adamantly pushing forward and creating the energy that's really accelerated this market and created a lot of the work specifically for the variety of different partners that are out there, creating to some degree this NASA approach well aligned actually with NASA. So Mark, thanks for being back with us. Looking forward to hearing some more of the details of this vision, and in particular, the role that we might be able to play to make this vision a reality very quickly. Mark, over to you.
Thank you, Nathan. And this has been really fantastic first 2 days. So congrats to your entire team there. So if you've seen any of my prior talks before, you'll know that I'm going to try to convince you that the technologies are real and game-changing in terms of the capabilities they enable, and that as a system solution, all the different pieces are starting to come together. But most importantly, is that there is a real business case for a vibrant market here. And that is really at the heart of Uber's contribution as the end user, essentially helping to get to the right place in terms of integrated requirements and capabilities. Next slide. So even though the technologies are really cool, that's not why we're doing it. We're doing this because society has a fundamental need, and that is, and more specifically, big cities are facing gridlock, and they need more choices in transportation to be able to keep them as productivity engines. Next slide. So I understand that there is reason for skepticism, right? I mean, we've had different transportation revolutions through the ages, but we've had the same solutions for quite a while now, right? The railroad was 150 years ago, the automobile 100 years ago, commercial aviation about 50 years. So we've had the same solutions for essentially an entire generation. So talking about something that's completely new and different, I understand the skepticism, but there's real opportunity for change here. And again, it's not just to change things, but because we need to have the new capability to move forward and maximize productivity. So in this next slide, you see just as how cities have grown up literally to take advantage of 3 dimensions, we need to do the same with transportation and be able to take to the air and overcome that gridlock and leapfrog into the future with new solutions that, as much as possible, give us a new clean slate to design things almost from scratch. And that's really much a rarity in today's modern complex society. Going to the next slide. In a nutshell, this is what we're enabling. And this is Los Angeles, a trip from LAX to Staples Center in rush hour, which in Los Angeles, lasts most of the day. So to be able to go that 16.5 mile distance, it takes about an hour and 20 minutes. What we want to enable is that you can do that same trip, but be able to fly go as the crow flies, and turn that into a 10-mile trip that only takes about 27 minutes. And to put this in context, the flying portion of that is only about 5 minutes. So we're really trying to give truth in advertising here that you've got to account for all the multimodal delays, because this very much is multimodal transportation, where we're integrating together for a true seamless door-to-door transportation solution or trip. The ground leg, the air leg, and the ground leg, and accounting for any waits and delays as people need to board and gain access to these different modes of transportation. So you see that as we go from an hour and 20 minutes down to 27 minutes, most of that time is spent in the intermodal delays. And the air leg, what you really want to do is provide, those access ports as close to where people are, so that you can minimize the ground time and delays and maximize the air time. Going to the next slide. So we at Uber, published this white paper, which kind of was the genesis of all this 3.5 years ago. And we specifically identified there were 10 barriers that really were stopping this from happening, and how we perceived that these barriers could be overcome relatively quickly as a collaborative ecosystem investment approach. And so we made this invitation for all to work together with us to enable this future vision of a new transportation choice for cities. Going to the next slide. Here's really the two fundamental ingredients that I need to talk about. On the left side, you can see the Uber app. On the right side, you can see one of our ECRMs, or common reference models, that we've shared with the world of what these new vehicles are going to look like. It really is the combination of these two things. You can't just say, hey, we will build a new vehicle and the market will come. It is about this integration across the different pillars coming together to enable a business case that has a vibrant market. And so it is as much about the first and last mile as it is that exciting air journey over this city. And as Uber, we very much over the last decade solved that first and last mile solution. So I want to get into both aspects of this. So from an Uber perspective, 10 years ago, there really wasn't on-demand transportation. The closest thing we had was a taxi, which had many, many delays and encumbrances, which isn't what you can experience today, where if you're in San Francisco or other major cities, you can pull out an app and in 3 minutes have a car there. And it's because of the scale of operations that we've been able to achieve very, very quickly. So starting with Uber Black, it was a very limited product for an exclusive few. But within just a few years, we were able to leverage that into UberX and then Uber Pool, where now we're doing over 15 million trips a day. And being able to have that, all those trips, is what gives this liquidity of access, which is critical for aerial ride sharing to work. And at Uber, we really have this perspective that we're a platform provider. So it's not just about being able to provide one type of vehicle, but to provide whatever transportation option makes the most sense for our users. So whether that's a bicycle or a scooter, or a pool trip or individual trip, or even access to public transportation, we're actively working with cities to be able to get those into the app and enable people to choose whatever best fits their specific trip needs. Moving on to the next slide. So as we started this, obviously I've been doing powered lift for 35 years now. That's all I've done at NASA. It's what I've loved. Even when I was a little kid, growing up, I knew that's what I wanted to work on. But helicopters, as much as I love them, are absolutely not right for what we need to enable this market. They're not good enough from a performance perspective, either in terms of the speed or efficiency to achieve a sustainable transportation solution, and certainly not good enough in terms of the community noise that is a real expectation that we need to meet, as well as safety. Going on to the next slide. So this is one of the electric vertical takeoff and landing concepts that we've been very much pushing to enable with our partners. And you can see, yeah, like any aircraft, the requirements are very much need to be focused on achieving speed, payload, and range, right? Because that's productivity. And aerospace, anytime you get into the air, it's much more expensive than being on the ground, because the consequence of failure is much more serious. So from a speed perspective, we've done lots and lots of simulations. And in fact, we have an incredible simulation team led by Ian Villa here at Uber, where we have studied with this Flux tool and understand the importance of productivity. And that's why all the partners that you see us working with on the vehicles are doing winged eVTOL, because we need that speed and efficiency that yields a range on the order of 10 miles to 60 miles, but more importantly, lets us fly continuously for about 3 hours with only 5 to 7 minute stops for loading and unloading passengers and topping up that charge, so that we can fly in those times in the morning and afternoon when you have to keep your fleet flying. From a payload perspective, we need to be able to pool together 3 to 4 passengers in order to amortize the other costs, in particular the pilot. So it really is critical. The business case does not make sense unless you do this pooled ride-sharing experience, which we've gotten really, really good at in Uber on the ground. Going to the next slide, it's not just about speed, range, and payload. We have to give the cities a sustainable green solution. And so we are committed, and have been from the very first days, of an all-electric battery-driven solution that has no in-flight emissions. Likewise, with the next slide, we've got to be quiet, way, way quieter than helicopters. In fact, our estimates are on the order of 15 decibels quieter. So we need to, and the reason for that is we need to be able to blend into the background noise levels of cities, which tends to be on the order of 60 to 70 dB, measured from a 300 to 500 foot distance. Helicopters are much more in the 85 dB at that same distance. We've got to be much, much quieter than that. And fortunately, that is where these distributed electric propulsion technologies shine, to get rid of that edgewise sliding cruise, because you don't have advancing retreating blades that need to spin at really high tip speeds. So we get away from those high tip speeds and get to much, much quieter aircraft. En route is just as important in terms of being quiet. We need to be at that 50 to 60, more 50-ish overflight at 1,000 feet. And that's why you heard me many times saying the best. It's all, this market is all about winged eVTOL. You can't be in powered lift mode flight with these multicopters at cruise, because you simply make too much noise with powered flight. As soon as you can get onto that wingboard flight, it really lets you get so much quieter at cruise. Advancing to the last slide, safety is critical. And again, distributed electric propulsion fundamentally changes the rules on how we can design aircraft to embrace getting rid of single part failure components, so that you can fail one, even two components, and still have propulsion and lift and thrust sufficient to maintain your flight and to complete the trip. That is a fundamental difference that helicopters have not achieved and never will achieve. And that's why these aircraft are so important to enabling the vision. Going to the next slide, this kind of shows the different pillars that we have at Uber, where on the right side you see what we're building at Uber, which is very much the software side of things. We are very, very good at software. We have thousands of the best computer scientists and programmers on the planet. So that really is composed of two different parts. It's the multimodal ride sharing and the Elevate Cloud Services, the airspace management portion. And you really can't separate those if you're going to have efficient networks. You need to be able to combine both together to sequence your operations seamlessly in order to have these efficient trips that are saving time, and that is our value proposition, is in time savings. So the left side is what we have invited our partners to do. And that is in terms of the electric aircraft. We're not trying to do it all. We know that there are aircraft companies out there that are much better at doing it, and we have partnered with them. Likewise with the infrastructure, there's real estate experts and architectural firms who can do that job better than us. And they have been very responsive in coming together with us to achieve this collaboration. Going on to the next slide. Here's our current 8 vehicle partners that we've announced publicly. Yes, there are more coming. And it's not just about us picking one as a winner. We want to enable all these vehicle companies to be successful. And just as proof for how enabling distributed electric propulsion is, and how much we are in a Wright Brothers era, look at those 8 different aircraft. Every single one of them is completely different. Every approach is unique. And that's, again, because there's such an opening of the design space that these technologies enable that no one honestly knows the best way to do it. And there is a diversity of missions, so that probably there isn't just one best way of doing it. Some are going to favor speed more, some will favor comfort. So we will have the equivalent of Camrys, Priuses, and Cadillacs in the air, and may they all be successful. We want to put them on our platform for our users. Going on to the next slide, you've heard me say for years how much I wanted to get the automotive companies into urban air mobility. And it was so exciting in January when Hyundai announced and showed their vision vehicle at CES. Not only that, but they pledged a massive investment over the next 5 years of $1.5 billion to enable their vehicle and their system solution as they work with us as partners. Next slide. Joby is also a very important partner to us. This is not just a pretty rendering. This is an actual eVTOL aircraft that is flying today. And to show you just how much I think of this aircraft, I actually asked Joby if I could have a picture of their early flight testing to show side by side to the Wright brothers. That's how excited I am about what they've accomplished and how thrilling it is to work with the future legends of aviation who are pioneering this. But Joe Van Beaver, being the modest person that he is, denied that request and told me to just show what they've already released publicly. It's also incredibly exciting that they partnered with Toyota, who really has an incredible long-term view of mobility, not just as a car company, but as an enabler of mobility solutions for the future, and really has, over the last 50 years, pioneered the mass manufacturing of automobiles with just-in-time manufacturing and so many other innovations. Now, I told Jay this is the sexiest slide that I have, not because of him, but of what he said at this event several months ago. And it's essentially said that there are 6 companies that are already well along their way in certification, and that, more importantly, there are no rule changes required in order for these aircraft to be certified. That's really important. So from day one, as we introduced our vision, most of the negativity, the criticism was, you'll never be able to get these vehicles certified. And just as others have complimented the FAA, I have to say, the FAA has been incredible partners to work with. They have been proactively enabling this future while ensuring that safety is improved from current day operations. Also, as you heard Jay say again today, it's really critical that we bring the community along with us on this ride, and that we all enter into the next phase of community engagement so that we can overcome any beliefs that may already be there from helicopters and enable society to see what can be and what will be a very quiet and safe future transportation solution that they'll be able to use and will have equitable access across society. Going on to the next slide, I really want to change gears from the vehicle into the infrastructure. You saw here our first vision of taking an elevated parking garage and turning the top deck into a skyport. Let's go on to the next slide, where we've compiled some of the different solutions that our architectural partners and real estate partners have come up with, where they're really looking at this as much more of a holistic transportation hub, where the top deck can be a skyport, but the other levels can be a transportation hub, where with one utility drop for an electric grid for 5 to 10 megawatts, you can have eVTOL charging during the day and autonomous electric cars and scooters and bikes charging at night to have a load leveling, which the utilities really need. Going on to the next slide, this really is a transportation solution that needs to be data-driven. We have lots of data at Uber to help optimize our users' experience. So placement of these skyports is really critical, again, to maximize the air legs, minimize the ground legs, get the skyports where they can be most productive, but also where they can be situated where the background noise level of cities is complementary, so we fit in as good neighbors in each area where these skyports are located. Going on to the next slide. Also, airspace access is a critical element of this, as others have highlighted. We've been really fortunate to have Tom Prevost from NASA join our team several years ago, and he's really instituted a fantastic collaboration with NASA, and kudos to PK and all of his team. As Davis highlighted earlier, we've had fantastic simulation partnering with NASA, and that's going to transition into validation flight testing. So really could not be more proud of Tom and PK and what they've already accomplished and will accomplish with airspace. Going on to the next slide, Tom has also been able to leverage our drone investment into early testing of the airspace through the FAA IPP program and our partnership with the city of San Diego, where those drone tests have been going on. So again, kudos to that team who has done an outstanding job of being able to incubate the technology and get them into operational testing. And that's why we're also already in New York with Ubercopter and being able to test multi-mobility, test the seamless integration in our app of selecting a trip if you're in Manhattan, you can essentially go in and open up the Uber app and choose for an UberX to pick you up, get you to one of the Manhattan Skyport heliports, fly you to JFK as a seamless integrated trip. So going on to the next slide, kudos to our copter team, which has done an outstanding job of pioneering multimodal trips. You can see here in this video of being able to select the apps. Also, they've established great partnerships with existing helicopter operators. We're currently flying the Bell 430, a twin-engine, incredibly safe aircraft. Again, we couldn't be more proud of what we've been doing with those operations to prove safe flight and multimodal. Going on to the next slide, all of this has to be wrapped into a business case economics that makes sense. So I'm really going to finish it up here. Helicopter economics just don't work. If you look at to the left, essentially they're about $9 per passenger mile. What we're enabling with these eVTOL aircraft is on the order of a 35% reduction, most of it due to reduced energy costs and maintenance costs because of the nature of the eVTOL. And that's from day one, even with an inefficient network. But as over the next few years, as we can optimize, get our load factor up, more pooling efficiency, using the eVTOL from instead of a few hundred hours, but up to 1,000 hours and eventually to 2,000 hours per year, that utilization and load factor are the key driving force to get these costs down to that UberX-like level. And to be, again, truth in advertising, UberX, you have the vehicle, you have the car to yourself. With Uber Air, you're going to be sharing the ride with others and pooling so that the costs are reduced through that sharing the trip. In the long term, as we bring in, again, autonomous flight, we're not dependent on it because we can do this with pilots in the beginning, but as we can bring in autonomous higher volume manufacturing, the next generation of lithium metal batteries, and certified thermoplastics, that really enables us to get to the next level of costs where this can compete, in our perspective, even with private car ownership. Going to the next slide, you can see here what we're anticipating. We're starting with just a few markets. By the end of 2023, we expect to be in the first market in one of our early adopter cities, and then have a crawl, walk, run strategy as we work towards many more markets. Going to the next slide, we have announced 3 partner cities where we're looking at early operations. This won't happen all at once. We're going to be constrained with the number of vehicles that we have and the need for our partners to be able to spool up operations in each of those cities. So it will take years to get across all these early adopter cities, but we're still committed to getting to the first city as soon as possible. Next slide, you can see, I mean, we've analyzed many cities globally, and there's just such a vibrant opportunity across so many large cities to help overcome their gridlock. I think I need to wrap it up. We're just about out of time. Going to my last slide. Again, this is not just about cool technology. This is about a vibrant market that has a valid business case. I lived through the very light jet days with DayJet. I have a lot of learning experiences there. That was a painful experience for a different part of aerospace. And I am absolutely committed that every dollar that we invest in this is practical, has a solution path where the critical path is not blocked. And with that, Nate, I'll turn it back to you. Thank you very much for your time.
Super. Mark, just a couple of quick follow-on questions, if you don't mind. The first one, as you know, obviously, the reason we're all here is because of the COVID crisis. What effect do you think this has? Is this a little blip on the radar, or is this a pretty big diversion from the timelines that have been advertised previously?
Yeah, so in terms of the timeline, again, there's a dependency on our part across all the different partners. We're actually in a very fortunate place where, again, from the last several months of announcements, there's significant investment that's taken place, and so several partners are very well funded. We see essentially no change in our momentum and our partners' momentum, and that we're all committed to enabling this safe, quiet transportation revolution in aerial ride sharing. Certainly, COVID was a surprise, and all of the companies will have to adapt to different experiences. Our team has been incredibly productive as we've learned to do a lot more through Zoom and work through with our partners in Zoom, and we found them also to be able to also remain incredibly productive in these challenging days.
Super. Thanks. Yeah, I super appreciate the feedback on that, and I'm looking forward to hopefully getting beyond this quickly, and it is also a blip on the radar. In closing, can you provide us, if you had your top 10 list or something very short thereof, what are the key items that you think the Agility Prime effort can do to help catalyze and to help move this market forward? And then maybe on the other side, what do you see as our biggest risk? What are the things that you don't want us to do? And I'll let you close with those two. You can pick whichever and how many on each side. But I think we'd really value that feedback and communicating that out to all our partners too, so that we can help and not hurt this effort.
Yeah, great question. So I love the way that you're doing this, right? We need, you're not throwing new requirements that are just military focused. You are trying to leverage and accelerate the flywheel, which is what we're all about too. So I'll give 3 different answers in terms of really significant contributions, and it's very much mirroring what Davis and Bob said earlier from NASA. Certainly enabling the airspace. And again, as I said, there's such great work that's already happening there. It's easy to get started, but, and be able to fly just as helicopters fly today in cities. But to get to scale, there's a lot that needs to happen, right? We need to get to voiceless interactions with the towers to have hundreds of vehicles and then thousands of vehicles. So airspace is just a critical place where different parts of government can come together to coalesce the solutions in partnership with industry. Likewise, that was mentioned earlier with security of the different comm solutions, especially as we get into the next phase after the initial piloted phase and into the autonomous phase. And so let me bring up a third one there, and that is that transition from piloted to autonomous. There's some evolution that's going to take place there. And as we've worked with Gamma, we have a working group that's essentially calling that simplified vehicle operations. I think it's absolutely so critical that DoD, NASA, and flight standards at FAA get together to help form a common view of how this evolution can and will take place, because there's still uncertainty there, right? I mean, we need to enable those simplified operations so that pilots can build up hours in this market and use those credits for other aviation markets, other commercial aviation. But it's not a slam dunk there, where we have unified control law pilot interfaces being developed. The F-35 in the military did such a fantastic job. There's so many lessons learned from the F-35 that are being leveraged. But the more we can have a common approach that we all agree to, the easier it is for flight standards to move forward, right? I mean, we don't want to train pilots in 10 different types of pilot interfaces and have pilots confused as they move from one vehicle to the other. We want it to be like a car, where if you get in a Toyota or a Camry or a Prius or a Lincoln Town Car, it's very obvious how that control interface is done in a seamless manner as you switch vehicles. So the last thing is, again, from the vehicle perspective, you mentioned a risk. I think we're well along the path. There's certainly lots of things to work out in special conditions. I think in the coming months, there's going to be a lot more information there. My worry in terms of risk is moving along the operational certification. I think there's so much work that has to be started there. And I would just encourage that across NASA, FAA, and DOT, and obviously industry, we really get that in gear.
Mark, thanks so much. Fantastic words, as always. Very motivational to see the energy behind this and the work that's happening every day that you are driving for. So thanks for joining us both yesterday